Morphologic Evolutions V1 with Dimitar. We're so happy to have you here, and I'll give an introduction of you. So Dimitar is an experienced architect, designer, and educator driven by his desire to create beautiful spaces, buildings, and cities that would that work excellently for all users. His design philosophy is based on creating beautiful architectures through the intersection of design, a sense of place, and technology. This philosophy drives both his professional and academic research over the years. Dimitar has developed a balanced, concept-driven design approach with industry-leading parametric design skills, having the ability to move from a sketch to a complex 3D model quickly and effectively is essential to evolve through design ideas efficiently. Blender is an essential part of Dimitar's toolkit, and he is on a mission to show as many architects and designers its key strategic advantages. He shows various use cases on his YouTube channel and teaches numerous courses. Um, so, um, Welcome to Dimitar, and for everyone that's here, if you want to chat in the chat, make sure you switch it to everyone. Also for you too, Dimitar, to switch it to everyone in case you want to correspond anything through chat. Um, and just a reminder that this webinar is recorded, and after the webinar is finished, within a day, you'll receive an email how to watch that recording. And since this webinar is recorded, if you feel that it's too fast for you during the live, um, just note that everyone learns at a different pace, and we want to show you as much as possible. So if you can't keep up, just sit back and watch, and you can always go back to the recording where you can pause and go at your pace. So that's it for me.
Cool. Thanks so much for the introduction, Mike. And thank you, as always, for inviting me. You know, you invited me to quite a few events, so I'm grateful for your support and for Design Morphine's support. And yeah, I'm really looking forward to teach you guys some Blender. Now, I have a couple of introductions from people. That's great. Hi, Leonardo. Hi, Sasha. It will be actually really interesting to hear from all of you. And in the meantime, we'll get started. So let me share my screen. Great. Cool. So that's kind of like the endpoint that I hope that we get to from here, and just to show you how we're gonna get there. Um, oh boy, I enabled something that's gonna take quite a bit of time. Anyways, while that's loading, let's do the introduction. Cool. So yeah, welcome to Morphologic Evolutions 1.0 with Blender. Just a little bit about me in case you don't know. Uh, I'm Dimitar Pouchnikov. I've done DRL and Mark program at London many years ago now. Uh, I've worked in London for most of my design career. I'm currently actually based in Bulgaria, but I've worked at AJ, HOK for over 7 years, who do all kinds of typologies. And what's interesting about my experience is that I've brought Blender along with me throughout my education and throughout the offices that I worked along. Nobody really used Blender or knew how to use Blender in any of those offices. I kind of taught some colleagues. And in fact, at HOK, when I started leading small teams, I decided, you know what? I better start doing courses because it takes too long to teach individuals in the office while I have to do my own work on top of that. So that's kind of how I started teaching in a way. It's like just trying to teach some colleagues, and then that eventually evolved into lots of different courses and online courses via UH Studio Design Academy, including my YouTube channel, which is a little bit stagnant recently, but my idea is to start picking up the pace in there because there's so many cool things that you can do with Blender, and I'm nowhere near done exploring all those and showing it to you guys as well how to do that. Um, yeah, so at the moment it's UH Studio Design Academy. I also run my own studio, UH Studio, which focuses mostly on parametric design. including with Grasshopper. I don't speak a lot about that, but I actually use Grasshopper daily and Rhino just as much as I use Blender. But, people like Mike and many others out there do an amazing job already teaching that. And I also work on architecture, residential, and urban design primarily. Cool. So here's just some of my projects. Mind you, all these are done with Blender. So, by the way, let me see if I can somehow pin the chat while I'm in full screen so I can see it. In case there's something important. Cool. Yeah, so this is a proposal for a tube station in London, some seaside restaurants, and then some residential projects, all designed and rendered in Blender. So clearly, Blender is a very important part of my workflow. So tutorials, all kinds, really covering a range of parametric design subjects and also architectural design subjects, and trying to sort of merge between those two. It's a weird space because on one hand you have people that are really interested in parametric design, and then another people that are really interested in let's say more traditional architectural design with Blender. So there's a little bit of both that I try to do. So these are some past courses that I've taught and some of the final results from there. And I also teach summer studios. So these are the results. Again, it's quite interesting because I sort of demand from my students that they use Blender. So on top of learning, in a typical studio environment, how to do the design that they requested, they also have to pick up Blender, for which I teach technical and both studio. So I do a lot of parametric explorations, and this is one area where Blender is absolutely excellent at because, as you will see, setting these up is really quick and, in a way, really fun because you're not too worried about the technical aspects as much as you're worried about doing design explorations. And I absolutely love that because to me, it brings the way I think and the way I do closer together. Sometimes, and I don't know if it's happened to you guys, I saw a couple of people already mention that they use Grasshopper. Grasshopper can get very technical very quickly, and I'll show you a little example in here as well. So that kind of takes you in a way away from design thinking and more into computational thinking, right? It's a little bit different. Of course, there's a lot of overlaps, but when you get like really into Grasshopper and trying to resolve some patterning, some optimizations, that's a workflow on its own, which I would say is quite separate than design thinking. What I love about doing these kinds of studies with Blender is that they don't take they don't take a lot of time. So essentially, they allow me to move as quickly from design thinking to production without worrying too much about the technicalities. Of course, as I mentioned, I still use Grasshopper daily, not daily, but quite often when I need to, because there's a space to be a little bit more technical and more clear and more defined. But as you will find out here, you can actually do a lot of that also with geometry nodes in Blender. So I imagine here everybody knows about Blender, but just in case, I will mention a few things. So it's a polymodeling tools, very similar to Maya and 3ds Max and Cinema 4D. But one of the advantages that it has is non-destructive modifiers, which work a little bit like modifiers in 3ds Max or the history tool. In Maya, I'm not really sure about Cinema 4D because I never used it. In fact, it'll be good to watch some tutorials because there's quite a few good ones. Anyways, what's interesting is that it's all polymodeling. So the workflows that you do with one of those softwares actually applies to all of them, including Blender. And Mike, I watched some of your courses on doing subjective modeling with Rhino, which is interesting. The tool set is still developing, but that's also applicable to what you can do with Blender. So besides polymodeling non-destructive modifiers, it has animation. You can do rigging, video editing, VFX, rendering with cycles and Eevee, and it has a large community that includes a lot of add-ons, and now it has geometry nodes. Something about the add-ons I'm going to mention. So the newest version of Blender is 4.2, and there's a significant change which I'll go over once we start the actual tutorial. So Blender is actually useful for architecture and parametric design for both design and presentation. In this course, we'll focus most on design, but we will touch upon presentation because I think it's always important to know how to create good presentations, especially if it is in the same software, like it can be in Blender, then all the better. So in it, we talked about poly, base mesh, design. We also have subdivision modeling. We talked about non-destructive modifiers, tessellations with the tissue add-on. That's a very important tool that you learn if you don't already know about it. And then geometry nodes. In regards to presentation, he has two rendering engines. He has Cycles, which is ray tracing rendering engine. So that's the same as V-Ray and Corona. And then he has Eevee real-time rendering, which just got a pretty big update. So it brought it much closer to, let's say, Enscape, Twinmotion, even in Real Engine in some cases. And then you can combine a lot of models from many different places. If you know how to do it, it's actually very capable and fast. Like it says here, capable of handling high and large geometry as well. Cool. So a question that I think should always, I like to always get out of the way when I'm teaching is, should I use Blender, Maya, or Rhino and Grasshopper? And here's a quick example that I had to do for a project for a Megato Tower in the office at HOK a number of years back. And it's a kind of a footprint, it kind of evolves when you take the elevation of this. It's a fairly straightforward model, but even something like this, for somebody that's fairly experienced in Grasshopper, these are the number of nodes that you need to do to create that. Now, I don't care how quick you are, how good you are at Grasshopper, unless you're doing like a Python script and you can do this in like 5 minutes, or maybe with ChatGPT now, even though, I've tested that and it still produces a lot of errors. Just putting all the nodes out there takes a lot of time, right? So that takes, from 30 to 40 minutes at least, right? A good hour maybe, just to sort out, because you always try and test things of doing them a couple of different ways. Because, if I do this and another person does that, chances are the script will be slightly different. Whereas in Blender, just due to the nature of the way that it's set up, you can actually be like really quick and really efficient. Here's an example of something similar, which is a three-way symmetry that you can set up. This is almost in real time here, right? So with a few modifiers, you can set it up like fairly quickly. And the nice thing is, because you can come up with with the setup fairly quickly, then you can spend a lot more time tweaking the design, adjusting the design based on the design criteria. So ideally, you get to a higher quality design faster. That's what I like to think. And then Maya versus Blender. So this is something that always comes up. So I did the DRL program at the AA, which is, if you don't know, closely affiliated with Zaha Hadid Architects. It's co-founded by Patrick Schumacher, who now, since Zaha passed away in 2016, is the sole director, principal. I'm not sure exactly what he is, but he's the director of all of Zaha. So he co-founded, and he still teaches actually at the DRL. So a lot of my friends have went on to work at Zaha, and a lot of them have moved on since. So they taught us how to use Maya there, and I knew Blender before that, but teaching it there taught me. I realized that I can actually do everything they're teaching me in Maya in Blender. So that's kind of how I got started with using it. So Maya versus Blender. So they're both fun and easy to use. They both have extensive modeling toolset, subdiv modeling, Python scripting with extensive API. In fact, I learned how to script in Python with Maya because it's so nice and straightforward. Blender is a little bit trickier, but still, if you know your way around a bit of Python scripting, you can do pretty cool things in there. And then they both have quite great interoperability with other software. Now, why are they different? So Maya has everything history. It has really easy Python scripting, and it has some NERP support, even though it's quite basic. Now, however, with everything history, it's useful at one point, but at another point, uh, people try to erase the history because the models tend to crash. So it's great, but it also negates it because a lot of times if you watch any tutorials, people have to sort of erase that. Whereas Blender has these quite straightforward and easy to use modifiers. I think it's actually in some ways the user interface is much more straightforward. And it has the tissue add-on, which is to me the absolute secret super weapon in Blender, as you'll see. And yeah, we talked about UI. Now geometry nodes. Geometry nodes is a little bit more like Houdini than Grasshopper, but as you can see, many of the things you can do in Grasshopper, you can also do in geometry nodes. And one thing people don't know is the Blender can be quite precise. So what are we going to cover in this workshop? So I'm going to walk you through some of the important settings, a bit of a modeling introduction, and then we get started really quickly, and we sort of evolve through a number of explorations, procedural workflows with modifiers, with geometry nodes, and with the tissue tessellation add-on. Finally, we'll be covering a bit of presentation. So that's going to be more diagrammatic. So a bit of materials, a bit of light, a bit of rendering, and then post-processing. So you're gonna get something like the image in the background. This is darkened a bit, so you can read the text a little bit better, but that's it. So here are some screenshots, of how we're gonna get started with some poly modeling, and then really quickly evolving, learning a bit of subdiv in the process, and then tessellating this. And then working a bit more with modifiers to see how we can deform these easily, but keeping them procedural throughout the process. And then a couple of different examples of that, and then getting a little bit more advanced of doing these kinds of more intricate tessellations, which, believe it or not, are super cool, super straightforward, and quite interesting. And yeah, they can be deformed in various different ways. Now, depending on where we get to, we might even cover something beyond this of even more intricate patterns and massings, let's say, with different patterns. So this, like all these tessellations that you see here, they're all done with the tissue add-on. So as you can see, it's a very important workflow into it. Cool. So let's get started. Okay, we talked about this file here. And yeah, so that's what we're going to cover. I'm going to just keep this in the background in case I forget something and I need to reference it. And this is Blender when you just open it. Now, you might have in here a box instead of a plane. I always like to start with a plane. If you don't know your way around Blender at all, let me turn on screencast keys. So middle mouse button, for you it's probably rotate. And for me, it's pan. Why is it pan? Because a friend of mine that works with 3ds Max, and he's a professional architectural visualizer, told me you tend to pan a lot more than rotate. So I was like, fine, I'll change my settings. And yeah, I'm quite happy with doing that. So 3D viewport, outliner, properties. That's the basic thing. Now let's go and jump into preferences, and I'm going to show you the preferences that I use. Now, note again, I'm using Blender 4.2. There's some significant differences, updates of how we use add-ons with Blender 4.2, and that is that there is a web-based extensions website that's hosted on Blender. It's called extensions.blender.org. I'll show you there in a second once we get to that tab. First off, interface. So I like to scale up my resolution, but that's mostly for you to be able to see a bit more clear. But it's really nice because, you can adjust it like super to your liking. I use around this. What else do we have here? I think that's it from here. Viewport is fine. Lights are fine. Editing is fine. Animation is fine. Where do we want to go into? So navigation is one that I have a few settings changed. So orbit around selection and auto perspective. I think auto depth is on by default. So I like to change this. By the way, If you don't have a mouse, I definitely recommending that you're using a mouse, but I imagine, you guys don't think you'll be using the trackpad. If you are, it's best to use a mouse with 3 buttons, with a left, right button and a scroller. So now on the key map, there are a couple of important differences that you should take note of. First off, as I mentioned, middle mouse action, the default is orbit. I set it to pan. That's a personal preference. Then the spacebar action, by default, it's play. And what happens? Sometimes we accidentally press the spacebar, and let me change this here to timeline editor. That's the default, by the way. And as you saw, we can really easily change any sort of UI space to another one. But now if I press play, the timeline plays, and that happens a lot where I accidentally press it. And you can set that to tools or search. So anytime you press search, you can search for absolutely any command that you can think of in here. I find that much more useful than having it for play. In this case, if you press shift play, that's how it plays, and escape. By the way, here, this is the frame number, so you can always see which frame you are. I'm going to remove my earphones because I sound a bit funny to myself. So I don't think anybody's talking. So that's all right. If anybody needs something, please raise your hand or mention it in the chat. Cool. What else do we need to cover here? I think that's about it. Then system. So if you have a nice GPU for rendering, if you RTX, like if you have an NVIDIA GPU, you want to use optics, or there's even an option on a Mac to use metal. So that's quite useful. Then the other thing is to change the undo steps. The default is quite low, so I make it 132. Then you should allow online access. That's just for the extensions. It's a new thing to do. Then save and load. That's all good. And file paths. This is a bit more advanced, but like it allows you to decide, like, specify your fonts, folder, asset libraries, and script libraries and things like that. But the default in here is fine. Right. So again, the important things to change is on the key map, as shown here. And then on system. So if you have a nice rendering GPU, it's to enable that. Okay. So the next thing we're going to cover is some of the extensions that we need to use. So essentially add-ons. And as I mentioned, something brand new with this version of Blender, which got released fairly recently, I forget exactly when, but a few weeks back, is that we can go to a website called extensions.blender.org. So brand new. What's really nice about this is that everything can get automatically updated. So you don't need to worry about updating it manually. So if you get them from here. Right. So in here, this is all, if you know what you're looking for, you don't even need to go to extensions.blender.org. But if you're just browsing and you want to see what's available, you can always go here, choose add-ons, because this also includes themes, and choose some of these ones just to see what they do. So back in Blender, in the preferences, once you get an extension, you can go to add-ons and enable them. So these are the ones that I have enabled. From these, the important one to mention is Sun Position. And Sun Position allows us to position light like you would in rendering in SketchUp based on a latitude and longitude, and with the specific timing, and the sun turns exactly in that way. And then Tissue, right? So Tissue is in here. So how do you install it? You look for it, Tissue. And then I think because I have it installed, I can't do that, but there should be a thing to click here. Let's see if I go to one that I don't have installed. Yep, it's right here, install. And there are loads of different ones. So it's quite nice that you can really extend the functionality of Blender. But for now, the only one that we really need is Tissue. Some positions. Some position is a good one to have. And I'll cover a few more as we go through the tutorial, the workshop. Now Blender automatically saves its settings, but if in case you want to, you can always go to here, these three dots, and click on Save Preferences to save. Cool. So now that's all set up. Everything else is more or less default. Okay. Except in here, in the outliner, your default might only have an eye. And what else does it have? I think that's it. Maybe the render icon. Let me go to one of the other ones. Yeah. I have a couple more enabled here. So how do you enable them? You click this little filter icon and you can enable these restriction toggles. So these are the ones that I have enabled. The click button, that's for toggling selectable or not. The eye icon is more or less like a temporary height. So if I press H, you can see that hides. If I press Alt H, that shows up. And again, H, and you see the eye icon disappears. This here is a, let's say, more permanent disability, lack of visibility, but also within the viewport. Now, something quite unique to Blender is that if this is hidden in the viewport, but if I press render, so window, I don't know if I have a sun setup. Let's just set one up really quickly. World. Change this to quite bright. Okay, so if I press now F12 to render, that's quite, there you go. So you see a person, right? Very, very crappy render, but you see the plane, even though the plane is not here. Why is that? Because we have this render icon enabled. So that means that if we see this camera icon, it means that it's visible in the renders. So there's two ways of manipulating geometry. So you need to be a bit aware of that to know like what is turned on and turned off. Because many times, even for myself, I have to double check before I render to make sure that everything that's turned off in the viewport is also turned off at render times. Now, we also have collections in Blender, which are basically layers. They call them collections, and you can create a bunch of new ones and nest them in any way you want. The nice thing about collections is that you can just press this little check mark and that disables it completely. So both in the viewport and at render times. So that's something that is a fairly newer feature within Blender, and I think it's quite important to use and to have. Cool. All right. So that's it with the settings. So now let's get started. So let's create some new geometry. So we can go here to the 3D viewport header, click on that, mesh. So 95% of the time, I start with a plane or a cube. Let's start this time with a cube. So we get this kind of cube over here. Then we have a toolbar on the side. By the way, we can expand this. If you click and hold, it becomes a double toolbar. And if we click and hold a little bit more, we can also see the names of the different icons. So in case you're not familiar with things, you can check them out here. I'm going to minimize this one here on the bottom. So this is the toolbar, and then we have something else called the sidebar on the other side within the viewport. So you have to click this little icon, which is a little bit hidden. But once you enable it, we get this kind of sidebar with different tabs. And we have something that's called items. So in here, we can see general information about our currently selected objects. So location, rotation, scale, and dimensions. So this is why Blender can be as precise as you want. Or as Irena says, yes, you can press N to show that, or T also for the toolbar. So these are definitely important hotkeys that you need to know just to make things a little bit quicker. Cool, so now with this object over here, we can start to modify it. And we do that by going into edit mode. So in here, we click on edit mode or we hit tab, right? So tab is to change between object mode and edit mode. And you can see it in a few places. First off, the header changes. It tells us very clearly that it's in edit mode. And also in the outliner, you see we get this kind of little icon here, which is an indicator that we're in edit mode. We can also enter edit mode for multiple objects. And what's the difference between object mode and edit mode? So in object mode, we can do things like move, scale, and rotate. But that's all on the object level. So you can see all these transforms that we did in object mode are appearing over here, including the dimensions, which is quite nice when we already know what we need and what we have. Now I'm going to add another cube. Let's move it. And what's the difference with edit mode? So now I'm going to press tab. We go into edit mode, and here we have access to vertices, edges, and faces. So I can click on a vertex. Notice, by the way, I am in select box, not in move, and I also have a gizmo. If you want to enable that, we go here in the viewport header. Under show gizmo, we click this arrow, and in object gizmos, I have move and scale. That saves me a click to move around, so I always like to have these enabled by default. And now we can move a vertex. We click here with type of selection. So we can click on vertex selection, edge selection, or face selection. And the hotkeys for that are 1, 2, 3 on the numbers above your keyboard. So not on the number pad, because the number pad is all about manipulating the view, like the camera view. But on the number, not on the number pad, on top of your keyboard, 1, 2, 3. So now we can move a face or 2. Let's move an edge. And that's basically it, right? So we can move these though as precisely as we want. How do we move them as precisely? If I click and hold the gizmo in a specific axis, while I'm holding, I'm going to press 1. And now that's going to move exactly, in this case, 1 meter up. We can do the same for a face. So I'm pressing 3, select this face here, and I'm going to move 5. So now that's moving exactly 5 meters. We also have the both global and local coordinates of either the face, so that's the median of the face, which is where you see this gizmo, or of a vertex. So if you want to be really precise, we can say that that vertex, if we change to global, should go at exactly 5 meters, at exactly minus 5 meters, and at exactly 18 meters. So we moved it around a little bit. So now if we go and see it in here, that should probably align pretty well. It's not. I don't know why this didn't become at 5. There you go. So it aligns to the grid pretty nicely. And we can do that with edges in the same way and faces. Now, what's the difference between global and local? So global is the coordinates from the origin. So those are just the general coordinates. Local is relative to the origin point, which is this orange point, orange origin. So if we go in edit mode now, and we check out the local coordinates of what we have selected, you see we have about 2.2416 for the X. Let's just move it in the Y axis. And the x-axis. And now if we click on that, we see we have the same because that's relative to this origin point. Irana 1, 2, 3, if you have it as views, again, it's on the keyboard, not on the number pad. Oh, and you have to be in edit mode. If you have it in object mode, 1, 2, 3 is a strange thing that's left over from older versions of Blender, which changes like your collection. It's a bit strange because I don't think a lot of people know that from the people that have picked up Blender as of the last 4 or 5 years. We used to not have collections at all. I mean, we were limited to 20, but they worked not very straightforward. Okay, so that's about object mode and edit mode. So let's erase these objects. We can erase by pressing the delete button. And now I'm going to top view. So how do you go to top view? A couple of ways. You can go here in this gizmo, which is like your Autodesk gizmo, right? So you can click on Z, you go to top view, X, Y, move around like that. By the way, if you have your keyboard in the preferences, your mouse set up with the middle mouse button being pan, if you have to click Shift and middle mouse to rotate. And vice versa. If you're keeping the default ones, middle mouse button is rotate, but if you click Shift and middle mouse, then you're panning. Okay, so one hotkey that I use quite a lot is the tilt button, and I always have to show that because it's hard to see. Let's see. It's It's hiding it. It's just below the escape button. So that little button on a US keyboard. And if you click on that, you get this nice pie menu, which allows you to do front, top, back, set up all the cameras, including you can do view camera. So we have some kind of camera setup here. That's what it sees. Or, if you're really far and, you're kind of lost in space, you can click on something on the outliner and then click on the tilt key and view selected. So I find that quite useful. And over here also, which is kind of like the sidebar region, we can toggle between orthographic and perspective view. So I find that quite useful. Cool. So let's go back to top view. And now we're going to add a plane. We already have a plane, but we'll do another plane. I'll move it some more over here. And let's erase these collections because we've got too many. And now, just going to look at my other file to see what we want to cover. Cool. So let's get started with modeling. So first off, if I go into edit mode, over here we see that we have the most basic kind of commands to edit our geometry and change it. So let's go to extrude region, and I'm going to extrude this exactly 1. Nice thing in Blender is we have access to the previous command in this sort of region over here. Right? By default, it's minimized. You have to expand it. And you see here that we actually can adjust that. Now, if I deselect something, it goes away, right? And if I do undo, it's not there. If I do undo again, though, and then try it now with some arbitrary thing, we can go back and without touching anything else, specify exactly how we're extruding and change all the settings that are available to us while we're in the command. Okay. Now let's do the other really basic thing, which is creating a loop cut. So I'm going to create a loop cut here by clicking the loop cut tool. And that's it. Next, let's go to select box, click on the face, this face over here, and we're going to move it. Right, so very basic box. What can we do? We can start to modify it. Now let's click on edge selection. Click on this edge over here. We'll start to move these inwards a little bit. Now I'm going to cycle between 1, 2, and 3 quite quickly and start to modify this. Very basic geometry. Now let's go to top view, Shift D to duplicate. That's a very important command that you should know as well. And while we have any kind of transform available, we can also lock axes by clicking the middle mouse button. So now I'm going to click the middle mouse button, which is kind of along the x-axis. And you see that looks really nice on the x-axis. Now I'm going to click the middle mouse button kind of on the y-axis. Well, first off, it disables it. Let's see. Okay, it has to be near the actual object, and now it locks on the y-axis. So I find that super useful to be able to move things around fairly quickly. Now we can type a specific number, and I'm just looking here in our 3D view header, and it tells us exactly the distance. While in the general footer, which I cannot click, but it's somewhere on the bottom, we can see all the hotkeys that we have available while you're in a specific command. So now let's type 5, and that's moved exactly 5 units. Okay. So one thing that I like to use a lot is modifiers. Modifiers live in this kind of area with the wrench tool in Blender. And now we're going to add a modifier. And we have a bunch of menus here. So edit, generate. We see all the different kinds of modifiers. Deform, normals, physics. The ones we're going to be using the most are under generate and deform. But the nice thing is, if you know what you're looking for, you can just search for it. So we can search for mirror and apply mirror. Now it doesn't do anything. Why doesn't it do anything? Because this is relative to the origin point. The origin point is exactly in the middle. So because that origin point is there, we're actually not mirroring anything. However, we can move that origin point in a couple of ways. First off, let's just duplicate that so I can show you different ways. If I go into edit mode, select everything by clicking A and then moving, you see that the origin point stays there because we're not in object mode, we're in edit mode, but our geometry is shifting. right? And I know the default cube or plane that we start with has a 2 meter by 2 meter footprint, meaning that if we move 1 meter, so while I'm holding this gizmo, I'm going to type -1, and that's going to be exactly aligned. Let's go to top view just to confirm. That's not top view over here, and that's correct. Now we can also move our origin point. That's a little bit hidden, so we have to go here in options in the top right-hand corner of the 3D viewport header and affect only origins. So now when we're moving, we're not moving the actual object, we're only moving the origin point. So I'm just going to move it here and we can see how the mirror sort of affects that. Now we have snaps, which is this kind of magnet tool over here. And the button next to it gives us all the options. In here, we have different options like increment, grid, and vertex. Vertex is the one that I use the most. So now if I click, we're actually snapping to a vertex, which is cool because we're kind of locked on moving along the x-axis. So any of those vertices that I snap over here, you can see that they snap on really, really nicely. So that's another way that we can do this with the changing of the origin point. I'm moving this around. So now, what does this mean? Like, any kind of mirror. So if you go into edit mode and we do some kind of edits, they're going to be copied up on the other side. So I'm just going to go to top view and I show you what I usually do. Because I already have this plane, okay, some kind of material, let's get rid of it. Shift D to duplicate it, put it over here, go into edit mode, create a loop cut in the middle, go to selection and just select and delete these vertices. X is the hotkey. You can use delete, but the idea is that your left hand is the one that you use most of the hotkeys with in Blender, and your right hand basically stays on the mouse, more or less. So in here we have this menu where we can delete different kinds of information. In this case, we want to delete the vertices, right? So we're only left with these vertices over here. And you see oh, that's moved. That's a bit weird. I must have moved something over here. Let's try by adding another plane. The hotkey for this let's see if it comes up. Yes, you can hover over any command in any of the menus and you can see the shortcut assigned to it. You can also search for shortcuts. So if you go to edit, preferences, key map, there you go, key map. And here you can search for absolutely everything. So we have the preferences. I think those should be in a separate kind of subtab, by the way. But anyways, they put them there. And in here, if I search for add, we can add a lot of things. What are we adding? Geometry. Let's see, property editor, outliner, node editor, object mode. Object mode, add, it's here. It's a little bit cryptic to know exactly what it is that you need. But anyways, they're all here. But the easier way to do it is either to add in here, or now that we have set it up, we can press the space bar, which is, by the way, the same as the F3 hotkey, and search for add plane. And again, you see the shortcut that's being displayed. Shift A, mesh plane. Now I know that's exactly the default. So the origin is in the middle. Something might have moved. Now let's duplicate this again. Go into edit mode, loop cut, put it exactly in the middle. Go to selection, select these two, delete vertices. Great. Now that should be exactly where it needs to be. Great. Now let's go to modifiers, add modifier, search. Modifier is kind of, it remembers your selection. So the modifiers that you use the most tend to come up on top. So you don't even need to type them. So there it is, mirror. Now, edit mode, edge selection. Let's move that edge here. Let's move that edge there. And I'm going to go into face selection. Select this face, extrude region. Let's extrude to something like that. Add a loop cut. What do we want to do? Let's add 2 loop cuts. So we can change the number of cuts here. So let's add 2 cuts. So now we have the 2 cuts over here that we want. And now let's go back to selection, edge. Let's move that. And as you can see again, it kind of changes everything that we have in here. And then that can stay kind of as it is. Actually, let's delete one of the loop cuts. So how do we do that? First off, we need to select it. We can either shift click all the edges. In this case, it's fairly easy because we have 3, but we can select the whole sort of loop by holding Alt and clicking. So now that's all fully selected. And if you want to delete it, we can go to the delete menu by pressing X. And here all the way on the bottom, we have an option to delete the edge loops. So edge loops. Now that keeps the geometry. Now what's the difference between deleting the edge loops and X delete, let's say, the edges? If we delete those edges, you can see that our faces go away and we still have those vertices there. So that's what we don't want to do, or X vertices, then that deletes all those vertices. So now we don't have any of these edges. So undo, Control Z, and now X loop cuts. Okay, so let's start to continue to manipulate this object. By the way, I have the snaps enabled. Let's just disable them here. And Alt click to move this edge around. And next, let's just duplicate this to start to form it a little bit better. Notice that my origin point is exactly in the middle along the x-axis, but it's not in the middle along the y-axis. We don't care about that because we're using the mirror modifier only in the x-axis, not the y-axis. That's how it looks in the y-axis, but we're not building our geometry to be symmetrical along the y-axis, just in the x-axis, for now at least. Cool, so I'll keep modifying this thing now by just moving some of these edges around. We just have to be a bit conscious when we're adjusting this to make sure that, anything that's touching the x-axis that's in the middle, so this inner axis over here, stays there. In other words, that we're not moving this, like that, or one of these vertices like that, because then we open up these gaps, unless that's the kind of design move that you want to do. Okay, so that's good. And now I am actually, well, let's see, how should we do this? So let's first off put this back here, duplicate it. I like to duplicate a geometry a lot just so we see our steps. And, sometimes if we make an error, we can always go back to the previous version. Now let's go into here again. And now, what if I want 2 loop cuts instead of 1 here? One thing we can do is select this whole loop cut by alt clicking on it, X loop cuts, edge loops, right? And go to the loop cut, make sure we have 2 number of cuts here. So now we have 2, or if I undo that, and we can bevel this. So we can click on this bevel tool, number segments, 1 is fine. It's all good by default. And now I can click and drag this gizmo, and you can see that we get these loop cuts. Now this is flat, so you don't see any kind of effect. However, if we do this on, let's select these edges over here, and now bevel, you see how they sort of do exactly what you imagine, which is like chamfering in Rhino, right? We can change the number of segments, and doing that is going to make it much smoother. We're just going to demonstrate by making 20. And you see that now that's a really smooth bevel, right? So, and we can, again, before I exit, we can change the number of settings here. So with number of segments, we can play a little bit with the shape, right? So we can make it like an innie or an outie. And there's some more options here, but usually there's a bevel modifier, so I tend to use the bevel modifier instead. However, if I undo this, let's change the number of segments to 1. For manipulating some basic topology, which is what we're doing here, I also find it quite useful, like what we're doing here. Okay, now let's move this face. Selection. Get the right one. Yep. Do something like that. Move that face a little bit out here. And move this face a little bit out there. Now we're going to apply subdiv to this shape. So Shift D to duplicate, lock the axis with the middle mouse button. Do some more over here. Okay, so now add modifier, search, and we want to use subdivision surface. And that's what it looks like by default. So this here is basically like Maya 3 mode, in case you guys are familiar. I think by now, probably everybody knows what subdiv is, how it divides the geometry. Each one of these faces gets a little bit, let's say, softer and gets divided into 4. So where we had 1 face, we now have 4. That's to the first power, to the second power, we have 16, and so on. Okay. Now, what if we want to keep some edges a little bit sharper than others? In fact, let's keep this at 2 levels. We can add creases. So I'm going to select these edges. So edit mode, edge selection, click, shift alt click to select this loop cut, select this edge over here as well. And now here in the sidebar, we have an option for mean crease, and we want to change this to 1. Okay. And now do you see how this automatically became quite nice and quite sharp? We can also do the same on the bottom. So we're going to do this by, we have only a few, so I'm going to shift click on them and increase the crease to 1. Now we have some kind of weird topology happening here, and I know exactly what it is, but notice how this is not like as smooth as it should be. Why is that? Let's go to X-ray mode by clicking this little icon over here. Not that one, this one. And if we go to face selection, it conveniently gives us like these dots to select the faces, right? So we can't select the faces unless we click the dot. So what do we have here? We actually, when we initially extruded, we also extruded these inner faces, which we do not need. And when we're using subdivision for the geometry, you see we have these kinds of errors. So I can get rid of them by pressing X and then faces in this case. And now you see that kind of oddity there, it goes away. So that's much smoother. Cool. So in here now we can start to play a little bit more with the geometry. If we want, let's select this whole face actually and scale it. And that doesn't look too good. Let's instead move that, just this edge, move it out so it doesn't look as strangely flat. And now move it up. And you see here, I moved it somehow in a slightly different way. So now let's try this again. It's almost looking like a mouse. Okay. And maybe we want to take this out a little bit more. Let's move this face over here. It's even looking more like a mouse. And let's do something like that over here. Cool. Now let's duplicate this. So Shift D to duplicate. Go into edit mode. Let's add a loop cut over here. Sure, we have number of cuts to 1. That's it. And now with that loop cut selected, increase the crease, set the crease to 1. And you see we have a different color when we have that crease. And now we want to kind of smooth this out, right? So a couple of ways to do it. First, if we select the whole loop cut, we can sort of just scale along an axis. But you see, we kind of get into these like problems, let's say, which we need to adjust later because that's not aligned into one axis exactly at the X local 0 axis. X or Y? Y local 0. Because we're because we're mirroring along the x-axis, so that has to be with the y-axis here. Okay. So I'm going to undo that, and I want to show you another tool that we can use, which is here, and it's called shrink and flatten. So now let's check offset even. And now we can expand this. Now, the nice thing about this option here is that it has, and it's weird because you can only see that option after you've done the command, but you have mirror editing. So that makes sure that like these, we look at top view, everything should be aligned along our Y axis over here. So we can move this in or out as much as we desire. Okay. And if we want, let's go back to our selection and we can continue to move things in any way that we like. Let's maybe move this out a little more over here. Something like that. Move this out a little bit more like that. That's the basic of subdiv geometry. But it's still nice because we're only modeling one side, right? So whatever we do on one side, as you can see, we get on the other side. This is quite cool. Let's keep that. Cool. So now we have some kind of basic shape. What can we do with this basic shape besides modify it? So let's start introducing tissue. So again, we have to go to Edit, Preferences, Extensions, type Tissue, and it should come up, and then click on Install. Once you have it installed, we have to do another step. Go to Add-ons. You have to search for tissue again, right? Expand it, and you see where it says Number Tessellate. So you have to install Number. So you have to click on that, and it takes a little bit of time for it to install. So make sure you do that, because Number is a Python library that speeds up things within tissue. So it might take a little bit of time, but it should work pretty well. And once it's installed, it will tell you Number module installed correctly. It's always a good idea to save your preferences, save Blender, or close it and open it again, just to make sure those settings stay with you, because if Blender crashes before you get a chance to save, Blender is actually fairly stable. It doesn't crash a lot, but it still does crash every once in a while, especially if you try to do some more advanced things. Um, in fact, I'm lucky enough that in most of my workshops, Blender does crash every once in a while, just to show you, and I find that useful to show you how good its autosave is. Anyways, so Number Tessellate. I jinxed it now, so it's probably going to crash at some point, so be ready. And that's it. So once we have that, tissue is enabled. So what does tissue do? First off, we have a sidebar over here with all the tissue tools. All right, so Irena has a question. So you see a timeline. And I don't have a timeline. So every window in Blender is modifiable into any other window. So, and every window header in the window in the left-hand corner in the header, we have this icon over here. So these are all the different kinds of windows available to us. So again, any one can become anything else. So here I can make this a 3D viewport, and now we have another 3D viewport if we want to, right? And that's totally independent of this viewport, so that can be quite useful. Or we can make this as properties. So we have the same window as this, as outliner, and you kind of get the point. So the default one is timeline, but because we're not really using, at least at this stage, animation this much, I tend to go to something that tends to be a little bit more useful, which is a shader editor, or in our case, it might even be object editor. So that's what you see here. And in shader editor, this is for setting up materials. We've got two options. We have, or three rather, but two that we actually use. One is for objects, so that's setting up materials for objects, and then setting up materials for world, shaders for the world. And yeah, like this is like really super modifiable. We can right click here in the middle and do like a vertical split, right? So we have like two windows like that. We can right click here, and we can also join areas. So that's quite useful. How can we join here? Like that. Right. Now let me see if I can join like that. Join areas like that. So we get back to what we had. For right now, I'll just keep this sort of minimized so it doesn't get in the way. So back to tissue. Oh, now I close the window with the screencast key. So let's just enable it again. Happy you find that useful, Irena. Cool. So what can we do here? So first off, I'm going to add a new plane. So Shift A, the hotkey. If I haven't mentioned it, I did, by the way, like for adding new geometry, Shift A mesh plane. Now, where does this plane go by default? You see it's not here. Where does it go? So we have something that's called a 3D cursor, which is this kind of weird looking thing over here. That's separate than the gizmo. Here we have a cursor in the tools. So if I click on that, I can move the cursor. Yeah. We can also snap the cursor to a specific point if we have our snaps enabled for vertices. And you can see now we're snapping exactly where we want to. So that's kind of cool. Or if we're not snapping, I'm just putting it here. We can also more specifically set up the location of the cursor. if we go here in view, 3D cursor, and we have the X, Y, and Z. I'm checking this because sometimes the Z goes like in a really strange place. Now it seems to be, you see, like, yeah, sometimes it goes to a strange place. I'd like to make sure this is at Z equals 0 over here. Okay, and so what does this determine? So if I go to now Shift A mesh plane, the plane goes exactly at where the 3D cursor is. So as you see, this is quite useful sometimes. It's a unique thing to Blender. It's separate than snapping. So we have this kind of snapping, but we also can do some interesting snaps with this 3D cursor. Cool. So now we have this plane. So that this plane is going to be our component, our panel for tissue. So let's go back to tissue. And let's do something to it though, right? Because now if first off, we need to select our component and then something that's called base mesh in tissue. So click and then shift click to select multiple. And then we click here on the tessellate button. And it tells us base is plane.009, component is plane.0011, which is not very useful. So we can actually name things in here. We can do it two ways. One is if I click on the object and F2, and let's call this P1 for panel 1. And you can see also it changes in the outliner. Now, unlike Rhino, we actually have access, and that's again similar through all the other poly-based 3D modeling programs that are similar to Blender, like Maya 3ds Max, Cinema 4D Modo, and whatever else is out there that Autodesk hasn't killed. And they all work in the same way. So we have P1 here, so we can double click, right, and rename things in the outliner. Now let's click on this and we can see which is the selection, and let's call this base mesh, or I just like to call them BM. So it's clear. Now let's click on this and shift click on that. So this is the last one. And now let's click on tessellate and it tells us base is BM and component is P1. That's cool. The only change we want to do here is click on merge. Okay. And now the first time you run a tessellation, it might be a bit slow. Oh, I know why. Because we have a subdiv on here. On 2. And that's basically like a big subdiv, right? Here we have the base cage and here we have a subdiv, right? Because right now our component is a really simple thing. It's just a plane. But what if we start to edit this? Now, this is all parametrically linked. This is where it gets super cool. So if we click on this, which is called by default tessellation, and if we go to this green icon, which is the object data properties, in here, if you go all the way on the bottom, just move myself out of the way here for a second. We have something good that's called a tissue tessellate tab. You can drag and drop these, so I like to position it somewhere up higher. Let's minimize these shape keys and expand this for tissue tessellate. And here we have loads of settings, right? So just walk you through some of the basic ones and then introduce other ones as we need to. So base object is BM, and we can change that whenever we want to. Component mode, we have P1 over here, which is for that. And again, we can swap this out. We've got thickness, merge, and so on. So since it's parametrically linked, we can go here in P1, go into edit mode, and now let's add a loop cut like this. And now let's move this up. Something very simple and very straightforward. Now let's go back into object mode, click on our tessellation here, and there's an option to refresh either here in the tissue tools or also in the object data panel. So let's click on refresh, and now it changes. And you see that it kind of works, but the alignment is a bit off. So that happens sometimes. So we just need to go into our base object and rotate some of the faces so we have the correct alignment. And that's pretty straightforward, especially when we have a low poly mesh like that. Sometimes it gets pretty complicated. Then we have to do something called UV unwrapping, which you may be familiar with or maybe not. So now I'm going to select all of these faces. And here in the tissue settings, or rather panel, we have rotate faces, left, flip, or right. So if you rotate them, it updates itself actually right away. And you see now they're more or less facing the correct way. I'm going to do the same for these here. So let's rotate them. And now they're going the correct way as well. And we need to do the same for this face and this face. Cool. So now this is all going in the correct way. So that's already like super quick, super fast. Now, let's go ahead and just change this a little bit. So let's disable the snaps. Move both of these faces around over here and make this edge protrude a little bit more like that. Okay. Let's go back to our tessellation and click on refresh. And boom, magically it updates itself. The subdivisions have an impact. So if we change the level of subdivisions here to 1 for the base mesh, now we have less faces. So let's see what happens here. So let's click on refresh, and that's how it looks, right? So it's a bit rougher, the geometry. However, we can also control it in a different way. First off, we can add modifiers to our tessellation as well. So what happens if we add subdivision? So it becomes quite nice and smooth as well, where we can change the number of subdivisions here also. Now, I just want to make sure, because some things are looking a little bit weird, we can check the normal's direction by clicking here in overlays, this little arrow, and under geometry, we have an option called face orientation. Okay, everything is facing the right way. So blue is up, red is down. So everything is blue, so that's all good. So that means just it's a little artifact when it's subdividing itself. Okay, so another cool thing is we can also add modifiers to our panel. So let's add an array modifier. So I'm going to look for one, click on array. So that's a very quick way. And this is what I love about modifiers. So we have mirror, we have array. These are ones that I use all the time. And we can do it because, we can also do this with geometry nodes now, by the way, but this is like super straightforward and super quick. And it's something that we use all the time. So one thing that we have to be mindful when we use the array one, especially when we're doing tessellations, is making sure that we have merge enabled. So let's click on merge, and essentially that combines these vertices here. Now let's click here on the tissue tools, refresh, and you see this updated itself again, and the geometry has a lot more subdivisions. So wherever we had one, now we have 3. So super nice and quick way to change things. Okay, so Leonardo says, when I click tessellate, it says an error, Python traceback. So when you enable tissue, make sure you have number installed. Then save your file, exit Blender, and open Blender again. See if it works then. Sometimes you need to do that for number to activate itself. Now, how do we get this to look a little bit nicer? I like to keep my shading as flat because it's easier to see, and I'm noticing that actually we're not merging everywhere. So let's make sure in the tissue properties, we do have merge. If we expand on merge, we have distance, and the default distance is quite small. So if we make this a little bit larger, now you see it merges much nicer. Of course, not everywhere, because here we have to kind of think about a different way, usually add some kind of edge. And this is also not merging exactly everywhere. Let's try 0.03, 0.05, 0.1. Yeah, it's starting to merge a bit more. And we're using relative. So relative is the distance that a panel protrudes that's based on the original face size, right? So if we make this larger, you can kind of see how the bigger panels, the ones that were bigger, they kind of protrude more, right? Like these faces here are smaller and it doesn't protrude as much. It's looking like some kind of angry animal. It's kind of cool. If we go to constant though, it keeps everything constant, and at the moment it's very big, but let's go to something like 0.2. And now that should merge a little bit nicer, although I'm still noticing, oh no, that is merged. Okay, so it might be just like some kind of shading issue because of the angle and so on. By the way, we're getting some odd merges here, so our merge distance is too big. Let's make this 0.01. That's better. And we can right click and shade auto smooth. And now that should start to look much, much better. Cool. I think we still have too many merges here, so maybe what we had before, 0.001 was fine. That's too small. 0.005, 0.008. Come on. 0.002. There you go. That's working all right. Why are some of these, even though are we on auto smooth? No, we're not. Okay, so yeah, in here we also have an option to do smooth shading, because if we don't enable that, and every time we sort of restart, or redo the tessellation by hitting refresh, it kind of utilizes the settings that are initially set up over here. Cool. So we can continue to carry this on. And a cool thing about tissue is that, let's say that this is linked. By the way, I think my object is too small. I usually work with objects that are more close to real scale. And I do have a person figure. And actually, this is a good way to show you how you can use the cursor. So shift right click. We can do the same as clicking the cursor and position it. And let's position it over here. And now there's a pie menu. If you press Shift plus S, that has to do a lot with the cursor. So in here, we can either, the two that I use the most is selection to cursor or cursor to selected. So now let's click on selection to cursor, and no matter where our person is in the 3D viewport, it goes exactly here. So I can see the scale a bit better. So let's go now in here and kind of make this a bit larger. In fact, I'm going to undo this. Let's get rid of that. Shift D to duplicate, move it some over here and make it a bit more generous. Here we can see the bounding box dimensions. That's a bit more like, let's say, pavilion scale. We can click and hold on these rectangles over here. If you click and hold on the blue rectangle, we're not locked to one axis, but we're locked on the plane. In this case, the XY plane. So it's quite nice. We can move anywhere around that plane, meaning that we know that the person's feet are basically on the ground. Yeah. But this is not on the ground. Why is this? Oh, we must have lifted some point, some part of it. Anyways, it's quite close, but if we want to, let's go into edit mode in here, select this edge, and in global, I'm going to put it at 0. And now you see that that's also on the ground. So yeah, a person fits in there, so that works pretty well. Now, we scaled in object mode, and you see here we have this kind of scale. What is quite important to do when we're dealing with modifiers, and that's including tissue, which is not technically a modifier, but in some ways it kind of works as a modifier, is making sure that our scale is 1-to-1 in object mode. So how do we change that? We have to go to Object, Apply, and here we have a bunch of options. We want to do Apply Scale. Once we do that, you see the scale is exactly 1-to-1. So we kind of apply that scale. Cool. So now let's go back to, I'm going to move this panel. By the way, notice now I pressed G. So instead of using the gizmos here, move, rotate, and scale, we can press G for grab or move. In Blender, it's called grab. So you can remember the hotkey G. And again, just like we can with the gizmo, I can click while this is active on an axis and it locks. Or we can also type an axis. So I can press X or Y or even Z. And now it's locked on the Z axis to undo. And we can press R to rotate. And you can see it's by default, because we're in object mode, it's using the object origin point, or S to scale. And again, with S, we can press X to only scale along the X, Y only along the Y, or Z along the Z axis. So we have two ways to do transforms. One is with the gizmos over here, and another way is with the hotkeys. They work similarly, but they're also slightly different. Sometimes it's useful to know one or the other. I tend to use both of them interchangeably. Okay, notice, by the way, that the size of our panel doesn't really matter. Because whatever the size of the panel is, all that matters is that it maps to that face. So it sort of gets stretched along those faces, right? So now let's do the same thing that we did before. First, click the panel, then shift click to click the base mesh, go to tissue and click on tessellate. All the default settings are fine. We just want to make sure that we have the right component in the right base. And click on merge and let's uncheck smooth shading. Click OK. Now we have the exact same thing that we had before. A cool thing about tissue is it kind of automatically remaps things if we duplicate them. So let's go to top view. I'm going to move this panel here so I know it's associated with this. And now let's duplicate both the panel and the tessellation. So Shift D, and I'm just going to move it down over here. And now if I change the panel array, so let's add a little bit more. And now if I refresh this, you see that that changed. If I refresh that, that didn't, because if we go to the tissue settings in the object data properties here, component mode, this is using P1. If we click on this, we can also see the name of the object we have selected here. That says P1. And this is P1.001. That's what Blender does. If we duplicate the same object, it just adds .001, .002, and so on. .003. And this here has P1.001. And again, at any point, we can sort of swap these out if we need to. Okay. And yeah, we can kind of like continue to expand this topology. So that's kind of what it looks like, right? So let's add a subdiv. There's shortcuts for subdiv. So we can press Control 1, 2, or 3, and that automatically adds subdivision. So now I'm in the modifiers. So if I press Control 2, we have a subdivision with level 2, with 2 levels. If I press Control 1, you see that it changes in the viewport 1 or 2. And we have a separate one in the render, which for the purposes of tissue doesn't matter. But sometimes what we want to do is have like one setting in the viewport, which is of lower quality, and then we can render out with something that has a lot more subdivision. More subdivisions means a lot more geometry, more topology. In fact, look at this. Let's see here with the status of the number of objects. So by the way, if you want to see this right here, you can right click and you can enable exactly what you want to see. It's also available in preferences, interface, somewhere over here. I think it is at least. Pie menus, status bar. Yeah, there it is, status bar. What we got. Okay, so now, oh yeah, so let's go and change. So notice the number of faces and the verts and tries. We have about, what do we have? About 10,000 faces, right? Now we have 25,000 faces, right? So it changes a lot. And now 3, we have 86. So the geometry count goes a lot up. So you want to be careful when you're using subdiv to smooth things out. I would say try to go as far as 3 initially, because there's a soft limit to go to 6, which is a good soft limit, believe me, because even now, like if we look at this geometry and uncheck optimal display, and you can see that is a super dense mesh, right? That's more density than we would ever need. If we change that now, you can see it's getting less and less dense, but still pretty dense. So yeah, you want to be mindful of that. And if we check optimal display, we don't really see the actual subdivision that's happening under the hood. Now I switch here to wireframe. So we can switch back between wireframe and solid mode. In fact, in solid mode, if we click on this, is it here? Yep. In viewport overlays, we can enable wireframe. So we can also see the wireframe and we can change the opacity so we see it more faint. I think that's quite useful to have. By the way, once we're done with this file, I'll save it and I'll share it here with a link in the chat before we leave the part for the session. So, okay, so now once we have wireframe, you can actually see a little bit better what's going on with the topology. So let's duplicate these two again. So Shift D and middle mouse click to lock the y-axis and move it over here. The same way we have an array here, let's add another array. Search, array. And we have relative offset, that's fine. Let's change this to 0 and the y to 1. And make sure we have merge enabled. And now if we refresh this, you see our topology changes because we added more subdivisions. So it's a really good way to have a super low poly base mesh and just modify as much as you want with the topology here. And again, like you can even think of this as being like flat topology. If you just want to add more subdivisions, but let's say you want to keep it uneven, because you can either do this with loop cuts over here, but the subdiv is actually quite nice because, you know, it calculates some things for you. So my suggestion is to keep the amount of topology, the amount of mesh data, like edges, vertices, faces, loops, to the minimal possible that you can get away with for what you need. Because the more loop cuts that we add and the more geometry we add, especially when we're using subdiv, the worse it tends to look. So minimum is better. And we can now add even more. So let's add two more. If I click on this and refresh, you can see how this is kind of becoming like a bit more evenly divided, but not quite, right? Because now our edges are a little bit sharper compared to what we've got over here, just because we have more loop cuts, right? So when we're doing subdiv, that area kind of calculates a little bit different. But it's just there so you're aware that you can do this and like really change your topology and have a lot of control over here. So I'm just going to take this down back to 2 to show you how that works. Cool. So the next thing that we can do is play even more with modifiers. I'm going to select all of these things here, Shift D, and duplicate them. And now again, this tessellation, because we duplicated the base mesh and the component, the panel that comes with it, it's all automatically linked to the update. So this is called bm.002. We can just double check that, bm.002. And this is called p1.003, so p1.003. So there's a really, really nice modifier that I like to use in here. And we're going to put that on the base mesh, because once we do that, then the tessellation is going to get updated. So let's go to add. It lives in the deform, and it's called simple deform. So what does it do? We can twist geometry here, either in the x-axis, which I guess for this object looks kind of weird, or the y-axis, that also looks kind of weird, or the z-axis. That also looks kind of weird, but once we subdivide, and we can even specify whether we subdivide before or after, or we can even duplicate a modifier. So if I click on Shift D, that duplicates a modifier, we can drag and drop the order. So I can put this after simple subdiv, simple deform. And you can see now that like we have something and then that gets smoothed out, and you know, it can become really smooth really quickly, right? And we can change the angle. So what's really nice about this is that these kind of twisting deforms, because they're done at a global level along like one of the axes, they always tend to look really good, and they preserve our topology, which if we start with pretty good topology, which we have, then everything works out pretty well. And of course, all this is modifiable. So we can go back into edit mode, and let's say we want to make this like really like way higher. That's looking pretty cool. Let's take it even higher. Maybe a little bit further out. How about we select, so edge mode, alt click to select this edge, and let's maybe move this a little higher. So we kind of have like a base that more or less stays flat, and then on top we have some interesting things happening. Yeah, so we've got this sort of subdivision now here. And now, if we want the patination to go along, all we have to click is refresh. Now, I have a lot of subdivisions here, right? So I did a subdivision once and then a subdivision again. Let's try first off to limit this to 1 and click on this here and refresh. Now it's a little bit better. And because on top of this, we also have a subdivision. So you have to be mindful based on your computer specs, you know, how many of these you do. Now we have an error here. We're not doing a proper merge. So let's decrease the merge distance a little bit more. There you go. That's merging really nicely. So you see that we get like something, I think it's amazing. Like with only a few moves, we can get something that looks like this good, which you can do, by the way, without the tissue add-on. In fact, I'm going to show you really quickly how you can do that. But there's absolutely no point to do that because you can do it with just like these simple moves and keep everything a lot more parametric. So how do we do that without tissue? We go in here. Let's turn off the simple deform. In here, in the modifiers, we have these icons in the modifier header. So the first one is whether it's available in edit mode. So if I turn off simple deform, you see it's going to be, and these are the same as in the outliner, right? So if I exit out of edit mode, I can still see it and it's going to render. We can also disable it in the viewport, but it's still available at render, or we can disable it everywhere. And I think, does that work with simple? Yeah, look at that. We can actually get the cage mode that's in the correct place with the simple modifier. Now, the tricky bit is though, and that works the same with subdiv, is that even though I have the vertex selected there, you see where the gizmo is. The gizmo is at the original location. So they haven't quite worked that out in Blender to have it in the correct modified location. So if I turn that off, you see like that's where it is. But if we turn the cage mode, it's there. So just something to be aware of. So for this, we don't need to. What am I doing? I'm just showing you quickly how we can do that in Blender without tissue. We can isolate objects by clicking the /. And that's local view. Okay, so how do we do this? We add a bunch of loop cuts. Let's check 20. Select them here. And I'm going to undo that and make sure I'm in edge selection. That's really important. So we have them here, here. And yeah, this is where it's a little bit tricky, right? Because that's going to be quite a bit different on the base and on the top. But we also have a little bit more control here, right? So I don't want to actually create loop cuts here. I only want them on the side, let's say. Okay, so now I can go to select box and we have to manually select these. So now I'm going to disable this subdivision. And with the subdivision, we also have a cage mode, so it's easier to understand and see. So now we have to select these loop cuts manually. So Alt Shift click. Just going to click that 20 times. We also have an edge ring, by the way. Maybe I could have used that edge ring selection. Okay, so now we have all the loop cuts. I think I want to select also this one over here. Select it. And now we're going to use bevel, which is what we did before. And let's change the number of segments to 2. We're going to do a very small bevel. And in here, we can change the width type. That's also available here before we do it, but I think it's easier to see it. And we want to use something like %, because we want to make that relative to the size of the face. If it's an absolute offset, you know, where we're shrinking the faces down, it changes a lot. Okay, so now we got these bevels. And what we want to do now is kind of move those middle edge loops. But how do we select that? So we can go to select, more or less, and select less. And now that gives us exactly the selection that we want. A really nice thing in Blender is that the selections are undoable and redoable. So if I press Ctrl Z, you see we have the previous selection. If I press Ctrl Shift Z, we have what we had selected before. So with this selection now, we can go to shrink flatten and we can simply move these out. And now, if we enable this subdivision again, you see this is kind of similar. I think we need like a few more levels of subdiv. to make it smoother. So it looks really nice, right? So let's click on Auto Smooth. And in fact, it has a little bit more control, right? Because we don't have like those. And, you know, to be fair, it's still like modifiable because we do still have these modifiers, right? Because we're only modeling one side. Then we're mirroring. Then we're doing one level of subdiff. Then we're doing the simple deform. Then we're doing another subdiff. And then this is actually auto smooth. It's a modifier now, and that makes everything nice and smooth at the end. So cool, but what if we want to change the topology? What if we don't want these number of vertices here, but we want less, you know, then that you basically, you know, you have to redo it. Sure, we can go ahead and like manually specify things and move things around. Like maybe we shrink flatten, just like specific things, which it's not even working with mirror editing. So we have to go back in there, select this vertex, go into item, go into local, and in the x-axis, we want to click 0. And now that's better, you know, that's looking, it's looking kind of cool, actually, I have to say. But you know what I mean? Like we can't really change those number of subdivisions once we've done them the way that we've done them here. Anyways, I think it's important that some things are known. Gosh, this is really crazy. Let me undo the bat wings. That's what it's looking like to me. Don't know what it looks like to you. And now let's compare. See, basically the same, except this has more topology. But if we go now and very simply on the panel, we change the array count to 4 and we refresh this tissue, refresh, maybe 5, and you get the point. We can have the same number of topology we've got here. Now here we also did it a little bit different, right? We're not just going, in fact, let's disable all of these and zoom in here just to see. All right, we have a vertex and we have these moved out. So that's a little bit different than what we've got happening with us over here, which is kind of like that, isn't it? Because that's how we built our panel. Our panel starts from here into here. Yeah, Blender, by the way, has a really nice annotation tool that you can use, and I find that quite useful. Just to do like quick sketches in the viewport, and it's by clicking this annotate tool. Okay, let's enable these again. I just noticed that I have a setting that I want to change on this. Here, pen. Correct? Yeah, that's correct. Cool. Yeah, so again, sort of like manual topology and topology with subdivision modeling. And the cool thing is, let's duplicate that so we can make it look a bit more like what we've got over there, which is just a little bit of extra topology. We have like loop cuts, right? So we can simply do the same thing that we were doing on all the topology, just on here. So how do we do that? So we can again use bevel segments too. That's fine. Click on this, and we're beveling. And now let's go to selection. Select these two. We'll make them flat. So if I have a specific snap settings, and even if they're disabled, if I click and hold, and while I'm in a gizmo, active one, if I hold control now, that temporarily enables, so I can snap to an axis. And now let's just move this up a little bit higher. So we have that extra level of topology. So now if we refresh, that's going to look, as you can see, exactly like what we've got there. That's the beauty about it, right? We can add as much topology or as little topology as we want. We can also, let's do this again, Shift D to duplicate. Let's put this somewhere over here. I have a little bit of annotation, so I'm going to erase it. Now, we can apply modifiers at any point, right? And if we apply it, that becomes real geometry. So I can click here on this arrow and we have apply. So now if I go into edit mode, what we can do is change just one of these. So it sticks out a lot more. So now let's click on refresh over here. And you see how it like sticks out a lot more. Now the trouble is that some of these panels, they're rotated slightly in different ways. So that's why they're not in the right place. And because this is not in the middle, it's not quite aligning. Now we can go back and sort of figure out our paneling, or we can undo this. And because we have an even number, we can just drag the middle one. Now, no matter which way our panel is rotated, whether it's the right way or 180 degrees, now that should align well. And there you see it. Sort of, yeah, looking pretty cool. Now, what if we don't want that bottom? We don't really need that. So we can go back to our original object and just select those faces in edit mode, X, and then delete the faces. And now we can refresh all these, by the way. If we select them all and click on refresh, that's going to be quite useful because we have less geometry available. And now those faces go away. So we can go to Shade Auto Smooth again. We have the subdivision applied here. And if we go to the tissue settings, again, we can change the scale. Like we can go even more extreme with this, like something like 3. That's too extreme. We can also go, by the way, in negative direction. So let's go to -1. Now, all of these are now going inwards, which maybe it's not so interesting in this case. And we also have some issues here with intersections. But what's quite nice is you can kind of see these gaps like working in a very specific way, which, you know, if you start to render that, that's going to look really nice. Let's go back to 1, or even try 2, which is quite intense, right? But it's looking pretty cool. Now, maybe we limit the effect and we make this stick out much less. So click on refresh. And that's how it's starting to look. In fact, maybe for now, I just keep this at 1. I think that gives you like a good idea of how this works. Now let's go even crazier. So with the simple deform, what should we do here? Let's copy these 3 things. So Shift D to duplicate. Let's see now. And notice there's something that's slightly strange over here, and it's just that those faces, in fact, what do I need to do? Let's select this edge and that edge. I mean, wireframe, the hotkey for that is Alt X. I find it, sorry, Alt Z, which you can see over here. I find that quicker than having to always move around the viewport, but before you remember that hotkey, you can always go here and enable wireframe. Now with sorry, not wireframe, X-ray. With X-ray, we can select objects that appear hidden, like in the back. If we don't have X-ray, for example, now here, you see I can select like all those edges. Let's do it easier with vertices. But if we don't have X-ray enabled, and we try to select those, we don't select any of them because they're all hidden except for some reason that one. Oh yeah, and it's a little bit tricky, again, because we have simple deform, which should really be turned off when we're in edit mode. Okay, so what did I want to do? Let's move these 2 faces slightly up like that. And let's move this somewhere. Make it even wider, why not? All right, And let's go here with something even a bit more extreme. Okay. And what if we try the opposite now? I think that, well, let's duplicate. Let's duplicate this and compare. So that's where the name of this workshop comes from morphologic evolutions, because we're doing iterative steps, so sort of like evolution, and the morphology just adjusts. Like all these objects are very similar to one another. Topologically, they're actually exactly the same, but the form, the location of the vertices slightly changes. So now let's go to edit mode, and I'm just gonna do this the other way, which is keep this down and put this up. Maybe this one here as well. I don't think this looks as good. Anyways, if we twist it, it might look interesting because, yeah, we're twisting it. And we can twist it a lot more. Right. And now we have something interesting happening here, which is that kind of loop goes somewhere over there. We can also add like extra level subdivisions so we understand what our topology is doing a bit better. And this is getting a bit dirty now because I think some of these are becoming very small and overlapping, but we can test it. So let's duplicate this tessellation, go into the tessellation settings, change out the base object from this base object, this one over here. And that's what it's starting to look like. I think let's decrease the level of subdivisions on the base mesh, the second subdivision. So change this to 1. And now let's refresh. That's like what's really nice about this workflow is like, again, no matter what we do, the topology is going to look really good because we started with a really clean topology initially, and we're just modifying that. I think we're going to be able to get quite far in this workshop. So yeah, it's pretty cool. Right. So what else can we do here? By the way, Blender is really good at saving even large files. This is starting to get like a bit heavy. And what I tend to do in this case is like here we have like 2 levels of subdivision. We don't need that. So we can change all of this and just to keep the Blender file a little bit lighter. Here we have a lot of subdivisions. I'm just changing them all to 1. I don't even know if this changes like the Blender file size. In fact, I'm going to see now because this is a modifier and it's not applied. So the underlying level geometry is the same, but I'm not sure. So let's just check it out. I'm just on another screen here looking at my file browser. And the actual file. Oh, wow. The file is only 1.2 megabytes. Amazing. So yeah, probably none of this applies. Let's just save this to C. Yeah, file size is the same. So actually it doesn't even matter. The only thing that matters is when we apply the geometry. That's pretty cool. Okay, so what did I want to do next? Let's go in here now, and we're gonna duplicate all this, and we can start to add even more deformations. So we can duplicate this simple deform, duplicate. And instead of on the Z, we can start to kind of stretch it out in interesting different ways, right? Maybe it doesn't need to be so much. Maybe it's just something like that. And we can change the order and it's slightly going to work differently. So you can see like, again, it's very interesting to experiment with this, especially the simple deform, because we can come up with very interesting solutions here. That's quite rich, I must say. However, now that we're lifting off the bottom, what I find useful is reintroducing those faces. So what is a good way to topologically put these back? Now we have 1, 2 faces. So all we need to do is go to edge selection, select this edge and extrude. I think that should work as well. Extrude region. Kind of does it in a strange way. That's okay. Once it's done there, we can go to item and make sure local X is 0. Now that's merged. So next, let's go to select box. Select this edge, shift select this edge and press F to make a face. Select this edge, shift select this edge, press F to make a face. Make sure that this here has no crease, even though it doesn't really matter because it's flat. In any case, when we're doing subdivisions, the crease do matter because they kind of have a pull weight that pulls more of the edges towards them. Okay. So now let's refresh this tissue, refresh. Look at that. Again, amazing. The exact same topology, the exact same panel. We're just doing some very basic, simple deforms. So we get like so many interesting evolutions, morphologic evolutions. Beautiful. Now, what I usually do to make that kind of, because you see here the direction on the bottom faces and the top faces is a little bit different the direction on the perimeter faces. We can do a couple of things. We can have a different panel there, or we can put like some kind of ring onto there. We're going to do that kind of ring with geometry nodes. So it's going to be maybe for some of you the first foray in geometry nodes. So yeah, I quite like this shape. So let's keep it. Maybe we can even decrease the level of topology here by reducing the number of arrays. So now let's refresh. By the way, if you press quick Q, that's a quick favorites menu, and you can put whatever you want in there. I use refresh quite a lot, so I put it in there. You can right click on any button anywhere in the interface. Right click. And you can either assign a shortcut or you can add it to quick favorites or remove it. So because I use that quite a lot, I've put it in my favorites, which is Q. And again, it's like quicker if I'm refreshing a lot to go to quick favorites and click refresh than it is to click refresh over here. All right. So now let's get started with geometry nodes. By the way, does anybody have any questions about anything that we've covered so far? If you do, please make sure you write it in the chat. I'm gonna have a sip of water. And I'm at the halfway point, so in like 30 minutes, 40 minutes or so, we're gonna have like a 10-minute break or so, just so you know. Cool. So is there a downside to using clipping in the mirror modifier with this method? So because we're using the origin point exactly the middle, so if we go back to some of these examples over here, Shift D to duplicate it, we don't even need to use clipping in here, right? But yeah, we can use clipping. So if I use clipping, if I move this around, you see it kind of clips anything that's along actually, what do I need to be? I need to be in object mode. What do I need to be? Hold on. A little bit confused. Okay. Yeah. So look, how does clipping work? So I'm moving this to somewhere over here. So that's away from the origin point. Now, if we enable this, oh no, doesn't select. But if we move all of this geometry closer, so in a way that it intersects, you see it clips, right? So basically, because we have vertices on either side, and when they're intersecting, we're getting that intersection point for it to clip. So you can definitely use that. I tend to never actually use it because I like to be a bit more precise with my data. But if you want, yeah, there's no real downside to using that. Anybody has any other questions? Feel free to shoot them. In the meantime, let's get ready for geometry nodes. So geometry nodes. So geometry nodes is a modifier, but it's a modifier. We click on new here with its own node-based user interface. So we have to go in here in this window and change to geometry nodes editor. And now whatever we have active with this sort of blue outline is the one that we see over here. Okay, and I'm going to call this perimeter ring. Perimeter ring. You can see the name here changed, so we know that that's linked. By the way, we don't want that geometry nodes to be on here. We're going to do it on an empty object, or like I call them like dummy objects. So I'm just going to put the cursor somewhere kind of close to where we are. Shift A, add mesh and cube. So the object doesn't matter at all because we're going to replace it. So let's add geometry nodes again. And in here, we have something that's called data in Blender. So we have an object and we have the data. The data can actually be shared between a number of objects. So that applies to mesh data. So that's basically like blocks in Blender. So what does that mean? So if I select this, instead of pressing Shift D, I press Alt D and I go and I edit one, like let's move this. You see that this is editing as well because these two separate objects are sharing the same mesh data. That's really cool because the underlying geometry can be the same, the mesh topology, but we can have a different number of modifiers on each of these objects. So for example, this one we've done one kind of twist, but with this we can do a different kind of twist. And that's independent because that's at the object level. So I'm just changing some random things here just to show you. There you go. And if we change this back, you see they're both changing, but because we're using sort of different topology, then they adjust themselves. How would you separate the model to different components like windows versus just form making? Well, that really depends on how you kind of set up your topology. Right now, we're sort of doing these, like, let's say, massing studies. So how would you put windows in there? First, you need to put floors, right? So with the floors, then you can have some windows in there, or you can embed that kind of intelligence inside of our object. So for example, if I duplicate this over here, we go to our base mesh and let's create some loop cuts, or rather, what do we want to do? Let's bevel. So I'm going to bevel this like that. We don't want a segment in the middle. And now let's do a loop cut as well. So click and hold. Oops, I added too many. 1. Okay, so if we click and hold, we can drag it somewhere here near the corner on one side and then on the other. Now, because we are actually doing this on one side and, we have mirror geometry, we can actually do the same thing we were doing with our base mesh, which is to use the mirror modifier. So the only thing I need to make sure is that I have a mirror an edge loop exactly in the middle. So I know that's exactly in the middle because we go to top view. Oh, actually it's not. So we need to adjust that. But now I can delete these faces, X faces. Now it's a bit strange, right? But that's okay because we're mirrored. So let's select this edge, go into item, make sure we're in local, and next let's put 0. And now let's add a mirror modifier and put that before the array. And now it's exactly like what we had before, except we have these extra faces in here. So now let's extrude this. So let's use the extrude region to something like that. I want to get rid of these faces here because they're kind of discontinuous. Right now, our topology is continuous in one direction and not the other. We can have these, but they're going to get kind of stretched. So it's more advanced, let's say panels. So X faces. Next, let's apply some materials to these. So let's create a new material. Let's call it frame. Now we have a surface and we have viewport display. I like to drag this out in the preview, like way down there, because I never use it. And the viewport display is the color that we see in the viewport. So let's apply some kind of material here. Or rather, maybe we can make it like green. That's just indicative, right? The actual geometry, like when we render out, happens in the surface. Now let's create another material. First, we need to create a material slot. And then a new material, and we can call this glass, and click assign. So that face now has this material. So if we refresh all this, you can see now that we've got this happening everywhere, and I'm noticing some discontinuities. Wonder why this is happening. Let's see. What should we see? Face orientation is correct. Everything is nicely connected. Might be merging too many things. Or sometimes we just need more levels of subdivision. No, there's definitely some kind of strange merging happening in here. So we need to go into here and just reduce that merge distance. And yeah, that fixes it. Yeah, oh yeah, that's right. Because we have a lot more geometry now, we have to be a lot more mindful of the merge distance. All right, so that's basically it, right? So I haven't specified it, but you know, like this material here could become glass. We can even like make it transparent in the viewport. Yeah. Hopefully that answers your question. And again, you know, this is like a storefront system, like a unitized glazing system. So it's continuous everywhere. Like if you want windows in very specific places, we can go and like modify this even more, or, you know, we can go and let's try this out actually. Let's duplicate both of these. Now I have too many subdivisions, so let's reduce this to 1 and this to 1 here. And what do we do here? There it is. So let's add another array, or I'm just going to press Shift D to duplicate this. And we're going to do the same thing we were doing before. And let's have 3. Now, for the purposes of this, I want to change the material every once, like here and there. We can do it procedurally as well, while we're keeping this array with geometry nodes, but that's a little bit more advanced. So first I'll show you how we do it directly in here, and I'm going to apply all these modifiers. So yes, let's go and install a tool that's called, modifier tools. So I don't have it installed yet. So if I click on install, it's available. And again, now we need to go to well, actually here it is. It shows. So modifier tools, what does he have? He has these extra 4 buttons where we can apply all modifiers, delete all, enable them all in the viewport, and expand or contract all of them. Now I just want to apply all to make this geometry real. And what I'm going to do is, actually, let's do it the other way. Maybe this is not glass. Maybe this is frame 2. Frame 2. And I'm going to just select these 2 faces over here. Select a new material slot, assign them, and now let's just create a new material and call that glass. Just give it a different viewport display color. So now we're gaining more control over our panel and subsequently to the places where we have windows. So if we refresh this, I go to refresh. Now topology is getting more complex, so redoing this sometimes takes a bit of time. And you can see what's going on here, right? Now we're getting these faces, and because some of our panels are flipped, they're not all appearing in the same place, which is actually interesting. It's a little bit, let's say, random, right? But this is one control where we can say, okay, these faces here, those become windows. We can, oh yeah, and we need to probably do them on these sides as well. So let's assign that. So let's refresh. And yeah, now we're starting to get windows. And the cool thing is once this is applied, we can have like a third material in one direction versus the other. Again, though, we have we have to go back to our original geometry, and the same way we were rotating some of the faces here, we need to rotate them here to figure out how, which direction is which. Is there no way to tessellate only for one side of the model or certain surface? Yeah, there are these options as well. So what can we do here with tessellation? Let's go back to something simpler. Let's go to this model over here and duplicate this. Let's put it some over here. Now let's say we don't want to tessellate everything. We know already that we only want these side faces here. So we can select the face loops in the same way we can select edge loops. So by clicking on in this case, a perpendicular face, alt click, and then shift alt click. So now we have a selection. Okay. So now if we go to this tessellation, we go to the tessellation properties. And because we know that it's already linked with everything that it was duplicated with, because when we duplicate it, it automatically knows, it changes itself. Again, I find that such a huge time saver than going back and manually resetting the base object and the component. Okay, so in here, there's a subtab called selective. So here we can choose on selective faces. So now it's only doing it on those faces. However, it does get a little bit tricky, it seems, when we're doing the mirror modifier. So let's try instead to have some sort of placeholder materials in here. Let's go to this material, create a new one, and we'll assign this to the second material slot and just give it a color so we're aware. So this is material index 0, this is material index 1. So now if we go back into here, let's just see if this works a little bit better. So instead of on selected faces, let's try material index. Yeah, that works smoother. Now you see we're isolating only to material index 1 or material index 2. And what if we want to have another tessellation, which is happening on top? So maybe we want a different panel for the different sort of material selections. So we can do that. It's again a little bit different and slightly more advanced, but not that much. So what do we need to do? So if we have our materials here, and I'm going to call this first material M1 and this material M2. So now we can have a material based on the selection as long as our panels match the material names. In other words, if we call this panel M2, so I'm going to rename it to M2, Shift D to duplicate, and we're going to call this panel M1. Now we can change this panel, so maybe, we don't have the array, so I can turn off the array, and that's a lot flatter. So oh, it's freezing here a little bit on me. Oh, didn't crash. Okay, got lucky. Anyways, so this is again M1. This is M2. That's going to match material M1, which is the sort of default material, and then this orange yellowish. So now with the tessellation, we have a slightly different option, which is component mode. Instead of using object, we can use materials. And now we have to disable this material index. And now we see that we have these materials. Let's just do something here that we can understand that we're doing something that's a bit stranger, right? I'm just going to do that and let's refresh. And because again, some of these aren't, well, this is simple enough. So let's rotate our faces. So it's only this face here that needs to be rotated. So all these are going in the right direction. So rotate once, rotate twice. That's correct. And we need to do the same on the bottom. Rotate once, rotate twice. That's correct. I'm almost tempted to do the same here just to make sure that we understand the direction and just fix all these faces for once and for all. So let's select this face and this face. Rotate once, rotate twice. There you go. Now we know that all of our faces are the correct way. Sometimes we have this issue with the mirror modifier though, where everything is flipped when we're using the mirror modifier. As we see here, there's no reason for this. And there is an option in the mirror modifier. I just have to remember which one it is. And I think it's, what was it? It's either mirror U or mirror V. I have to play around to figure out. Yeah, sometimes this is a struggle, but I get stuck on this point a fair bit of times. So let's see, instead of merge here, maybe this is here and let's try that. Yeah, I'm not sure at this point which one it is. That's why I try to keep it like fairly straightforward and simple. But there's definitely a way, and it's one of these settings to make sure that the mirror works correct, or we can just apply the mirror modifier once we're kind of sure what we're doing, because when with an applied mirror modifier, just duplicate this, apply mirror. Whoops, I duplicated instead of apply. Apply. Now what happened? There you go. Okay, so we can still kind of edit things quite nicely, even though it's one geometry, right? By just simply scaling along as an axis. So we can do this. We can do that. Now it looks like a bike seat. And we can do that. Something like this right here. All right, so you see how we can continue to modify things in a nice way, or just selecting these two. Something like this. Okay, so if we refresh, everything gets a little bit screwy, and that's okay, because now we know that we need to just select the faces that are on one side. Let's disable subdiv for a second and isolate the selection, because we know we only need to select the things on one side. We have everything selected. Yep. Let's go back. Tissue. Rotate faces once. Rotate faces. There you go. This face here is to be rotated. And now everything is the right way. Let's enable this. Let's enable that. And you see we have everything sort of like nice and smoothly working. And now with this, once we have the mirror modifier applied, even if we go back and did what we did here, which is make this a bit more directional, if we apply it, that should work correctly in all cases. All right, similar to what we've got here. I think this would be a cool shape to try to do simple deform. Again, like kind of twist it, duplicate this. Seems like along the y-axis works pretty well. Probably not with as much. Now let's see that. Look at this. Again, exact same topology that we're using and so many different results, right? Except we have this gap here that we need to address, right? Which is what we're going to talk about next. But hopefully this gives you an idea about the different ways we can manipulate material selections. So we can have, you know, an unlimited amount of faces. Like each one of these faces can have its own like a material or object tessellation. So let's go back to here. So we talked about this. So I'm going to go back to a simpler version, which is over here. Quite happy with this result. Right. So geometry nodes. So we already created something, right, which doesn't have anything, and it's called perimeter ring. So I'm going to just click it here. We can use the tilt key also in here to have a view menu. So frame O to select everything. So geometry input and geometry output. Now I'm going to drag two things in here. Well, because I'm not quite sure which one it is. Instead of dragging, we can add nodes in the same way we can add geometry. First, we can do it here, and we have a lot of different selections, or we can press Shift A, and we can either search, or we can start typing Shift A. And I know I need an object info node, and it comes up. And now let's click on this edge. And in fact, we should have a different material. That's important for us because that's going to help us with geometry nodes. And I'm just going to use the ones we have already set up, which is M1 and M2. Just assign M2 to these faces. There you go. So now we know we have like one area. So that's going to help. So let's click on this cube, which is, you will see we won't use the original geometry at all. So now we have the correct selection. Let's plug this into here. And you see, we just get like an exact duplicate. And if we move it around, it sort of just positions itself around. Now, what we can do within geometry nodes is separate the geometry based on material. So I'm going to Shift A and type separate geometry. And let's click on this, and it automatically links itself. So there's some certain things that I actually really prefer in geometry nodes compared to Grasshopper, in terms of just how you can edit things, you can move things, connect, disconnect things with nodes in Blender that I wish Grasshopper had as well. So separate geometry, we want to use face, and we can drag, by the way, in Rhino 8, we can do something similar like what I'm going to do here, which is drag out, and it gives us like a pop-up menu in Rhino 8. If you use Grasshopper in Rhino 8, it doesn't have quite this yet where you can search for anything, but you can kind of like add different shortcuts for things. And in here, we want to type material selection. Okay. And now we can type M2 because we know that's the material. So now we only have an object with that specific material. So it's just isolating it, and it's all completely linked, right? In other words, if we go back now and we just modify some of our geometry by, for example, adjusting some of these simple deforms, you see this actually adjusts itself completely quickly and automatically. Now, question that you might have is, okay, if we have like this with geometry nodes, do we have tessellation in geometry nodes? Yes, some people have done tessellation groups. So you can do groups in geometry nodes that combine like complex, um, um, a lot of nodes into like one group. But from all the ones that I've tested, none of them come close to having all the options of the tissue add-on just yet. I'm sure in the future it will be possible. Somebody has to do it, right? But especially with like the rotations, things can get quite funky. That's why I still prefer to use the tissue add-on as opposed to like a geometry nodes based tessellation. Okay, so now what do we want to do? We want to just get the top and the bottom rings of this. And we can do that by thinking about this a little bit, right? So if we look at these vertices here, these edges, this edge has only one neighboring face. Whereas this edge and all the other inner, let's say inner edges, they have 2 neighboring faces, or you can even say 4 or 5 neighboring faces. So we're going to use that to sort of like isolate our geometry just with these like top and bottom edge loops. So kind of really simple and really straightforward. So I'm going to duplicate this separate geometry. So Shift D, and we're going to kind of drop it in there again. This time we want to use edge. Let's drag selection and type compare. And this gives us like this kind of selection based compare. Notice that we have like different like colors and shapes of inputs and outputs. So the circle ones, they're static. So we have like one data that doesn't change. The diamond shaped data, these are called fields in Blender. And those are like adaptable to like whatever the selection that we have. Now let's drag this and we're going to say neighbor, edge neighbors face count. We want this to be equal to 1. And now you see we get like a really nice selection just of the top and the bottom rings, which is exactly what we want. So now we can turn this from mesh to curves. So, and because I know what I'm doing, I can just search for things. But I really encourage you when you started with geometry nodes, first off, look at, there's quite a few online tutorials already. Aaron Dale's channel on YouTube is probably the best to like just look at computational usage of geometry nodes, because you can use it for a lot of things, especially for instancing. It's quite useful for that. But as you can see, we can also do like some basic straightforward things like what we're doing here. And so I do encourage you to kind of explore the menu with all the possible like geometry nodes in here. But for now, I'm just going to not go into like a large amount of detail because that's just going to take like the whole work. That's a different workshop on its own. But just cover the things that we need in here, which is to add this sort of perimeter. So Shift A. And by the way, I've added a hotkey here. We can do that anywhere. Like we can add a shortcut if we have a specific thing that we use a lot, so it shows up for us. So what am I looking for? So Control A is my shortcut in here, and mesh to curve. Okay, so that converts it to a curve. Now we're going to convert this curve to mesh. And this is another thing that if you see now, if you know Grasshopper, you'd be like, wow, why can't Grasshopper do sweeps just as simply? And we're going to do a sweep, which is just using a profile curve. We can use any kind of shape we want. It can either come from within geometry nodes or we can grab out external geometry. Right now, I'm going to use a curve, primitive quadrilateral, and the default one is really big. Another useful tip, anywhere in Blender, we can click, hold, and drag to select multiple properties at the same time. Let's make them something quite small, like 0.1 meter. And now if we put this into the profile curve, you see we get this kind of nice curve. What if we want to have like more subdivisions? We can do that by adding a subdivision in here. Okay, so Control A, subdivision surface. There's quite a few subdivisions. So subdivision surface is the one that works like the subdiv modifier. We have some other ones in there as well, but that's the one we want to use. And we can change the level, and you can see this is getting much smoother. If we change the size, it is also getting quite larger. Cool, so now we got what we want. What we need to do though is position it. There are a couple of ways to do that. One is, remember I mentioned that we can use the cursor before to smartly position things. So this is how we do it. So we press Shift S, we put cursor to select it, and now we select this and Shift S, selection to cursor. Now that goes exactly where it needs to. Now the curvature is a little bit different. Why is that? Let's see. Is it because we have subdivision in here? No. Are we using the same BM006? This is BM006. What are we using here? We're using BM006. So why in the world is this different? What else could be causing this to be a little bit different? So we're using mirror. We might, let's just do a refresh on this. There you go. I must have changed like some little property and I didn't refresh that. Now that everything is refreshed, you see this aligns like really nicely. And now this is just called cube. So let's go, just change the name of it from cube to perimeter ring. Okay. And now in here, we can just change the size of it to make it a little bit bigger. So it kind of absorbs, let's say, a little bit of like the geometry. If it's not quite aligning, we can also move. So Control A, transform node, transform geometry. Click this. So we're only going to move the sweeping shape, which is this quadrilateral, in relationship to their curves along either the X or the Y direction. And we're going to do that very smallly. So you can see if we go positive, we're going under. If we go negative, we're going up. And that's exactly what I want. And that's correct throughout this. So now that's looking really nice. And it's all, as you can see, super parametric. We can also get quite interesting shape. So I think, is there a star shape by default? Let's see. Control A, star, curves, primitive star. Yes. What is this going to look like? Pretty intense. You get the point. Let's reduce the number of points. Can change the inner radius or the outer radius. Oh, we can even twist, but because we're sweeping, I don't think this is going to do anything for us in this case. And that's quite heavy. So let's go back to our good old quad in here, or, we can also use a circle. We have a mesh circle or curved circle. We want to use a curved circle. So if we plug that in, that's what we get. Exactly what you imagine. If we change, by the way, the resolution to 4, it's exactly like using this. Except it's a square profile, right? So we only need to change the radius to something like 0.7. All right, so that's all kind of linked. But now, what if we decide to duplicate everything? So let's go in here. Shift D to duplicate, and we move that. Okay. Now, if you change this around, let's just, I don't know, twist it a little bit more. We're going to refresh that. That's updating, but this is not. The ring is not. Why? Because in geometry nodes, it's not quite that smart, and we haven't told it, let's just select this quadrilateral, that this is using the different object. So we can go in the perimeter ring object settings here, and we can change the object info. Remember this input that we have? We can change it to here. However, notice this changed and this also changed. Why? Because both of these rings, they're using the same uh, geometry nodes data. That's why it's linked. So it's kind of cool because it's duplicated. But then how can we export things, or do we can make this a unique, but there's a really, really cool setting, which is we can expose some inputs per instance. In other words, even though these two are sharing the exact same data, we can tell it that we should have a different object that we select by simply dragging one of these inputs into the group input node. And now we can see this property. Let's undo that just to see. This is the geometry nodes modifier in the modifier panel. So now if I drag this out, here we have an exposure of the object. So if I go back to here, let's uncheck that. and click this one, you see, even though they're using the exact same geometry, in other words, like we can go and we can change, let's say, the thickness. You can see that both of these adjust themselves, but they're using a different geometry. So that's a really, really useful thing to know, because we can expose any kind of setting. In fact, if we want to change the width, we can do that. And we can even duplicate this group input. So Shift D to duplicate it somewhere over here. And if we export the width, so like it allows us to keep the geometry nodes tree looking a little bit cleaner, right? So we have a width, so that's per instance. So I can change the width to 1. Let's make this really white. Meanwhile, that's staying what it was before. Really cool thing. But for now, I'm going to erase that. How do we change the group inputs? In the node tree window, we have this little icon here for a sidebar. Or again, we can press N to show it up. And in here, we have like different tabs. So the group 1, node 1, and so on. So in the group 1, this is where we modify like the group sockets. So first off, we can rename these to like some smart name. We can add more if we want. And it asks us whether it's an input and an output, or if we have a lot of things, we can actually put them in a sub panel, right? So here's the panel. And if we want, we can drag this width inside of the panel. Come on. There you go. And we can rename things. So it's adds like such cool flexibility to all of this. So now I'm going to get rid of the panel and get rid of the width. And now we're back to whatever the parameter is, which is for everything else that we utilize here. So that's a very quick introduction to geometry nodes for geometry and architecture. Next, so we're going to take a 10-minute break. And after the break, we're going to continue with more modifications. So we're going to get into geometry nodes a little bit more, and we're going to also look at more advanced panels. Meanwhile, if you guys have any questions for anything else that we've covered so far, make sure you write it down. Okay. See you guys in 10 minutes. Hey guys, sorry, this was a little bit more than 10 minutes. Yeah, sorry about that. Anyway, so here we are. Let's see, maybe a bit off topic, but in order to print these kinds of shapes, is it possible to give thickness to the whole object, maybe through a modifier? Absolutely. So Blender has a really cool modifier. There's two ways to do it. One is, let's go back to, let's see, are these solids? There are solids. Let's take this one. Although it does have a cover, but you know, like I have a 3D printer, so I do tend to 3D print even these kinds of objects. And you know, you can just put this in a slicer and it's going to automatically like merge like some of these distances. So this is already like 3D printable because it's going to make it a solid, right? If you want to print a shell, 3D print a shell, and in fact, this is good because there's another exercise that I'm just looking at, like my prep file that I did and that I want to show you, which is based on a shell. So let's just do it, and in the process, I'll answer your question as well. So Shift A, let's add a square, and we're going to do loop cuts again. Now, similar to the way that we have tools for move, rotate, and scale, we also have similar things for, let's say, tools that exist in the toolbar and hotkeys. They work similarly, but they're a little bit different. Like, again, this toolbar is a kind of a fairly recent addition to Blender. Before that, everything used to be done with hotkeys, right? So that's why we have like maybe two different ways. I tend to teach mostly how to do things with the toolbar because it's a little bit more accessible. Like you don't need to like search through the menus, which by the way are over here. Like we're in edit mode, right? So we have a vertex menu where we have a lot of commands, some of which do exist here, but not all. For example, rip region. Underneath of here we have rip edge, which is the same as a rip well, actually. Yeah. So similar along the lines, and we have then edge. So everything that has to do with edges. Edge slide is one I haven't talked about, which is quite important, but that does that is it here as well? Instead bevel. No. Oh yeah, there it is. Edge slide. So we do have it as a tool. So they did kind of pack like the most important tools that we have from everywhere into here. What else do we have? So we have like a lot of ones for face. One that we did use already is kind of fill, which is like make face with the F tool. And then we have UV. But also we can right click and we have like this is context sensitive. So it looks one way when we have edges here. If we go to vertex, then we have like more commands that are along the vertices. And then if we have faces, it's also a little bit different. So again, this is, how shall I say, everything we absolutely have is here in the menu header, right? So in mesh, vertex, edge, and face, yeah? We have a slightly more constrained version in the right-click menu of commands. And then we have an even more like constrained, let's say the most widely used tools, but these are tools with their own gizmos. So that's a little bit different, which are here in the toolbar. Okay, hopefully that gives you an idea of where to find things in Blender, because sometimes, how shall I say? So there isn't like a, well, I guess you do have like this here as like your header where you would be able to find everything, but you have the toolbar and like some things exist here, but they don't exist there. Um, right click is the same as mostly everything we have here. We do have some things in the sidebar as well, which is mostly for information, except where we have add-ons, right? So they live mostly here, not all of them, but mostly in here, right? So we kind of worked with a solid in a way, even though you can consider this a shell as well. But now I want to show you like a, let's say a more typical shell, which we're going to use the mirror modifier for again. So we did two divisions, so I talked a lot, so let's just redo that. First, I'm going to put our cursor to the selected, then going to edit mode, delete this, Shift A, add mesh plane, just so we have another plane. Let's go into edit mode and press S to scale this quite a bit more. And now, fine, I'm gonna stick only to the ones here. It's a little bit tough for me, but I think it's better for you guys. Again, it's a little bit more accessible to use the tools that are over here. So loop cut. One in this direction, one in that direction. 4 quadrants. We're going to use mirror in both the X and the Y direction. So let's go to selection, select all these. Control Y, by the way, we can invert the selection. Selection does have a lot of useful commands in here, like we can select loops that we have. We can select similar things, which I haven't talked about, but let's see. Hopefully there's a case that we can cover it. Yeah, so it's quite useful in many cases. Anyway, so back to this. Let's delete these faces, X face. Now we have only one face with an origin point in one corner. So now if we add our mirror along the X and the Y, it's perfect. So now let's do some kind of a fairly typical shell type of condition. First off, you see, I'm so used to my commands, which is Control R for loop cut. But let's do this here and this here. Now let's select this edge and this edge, and we're going to extrude them with extrude region. I'm not sure which direction this plays with. Where does that extrude? It kind of extrudes up or down. So of course, there's another way to extrude, right? Like what I just covered, which is probably one you should know because it is one that tends to get used quite a bit, which is E for extrude. So it's a straightforward one. So E to extrude, and then we can kind of go, yeah, more along this direction. Orientation, by the way, we can have normal direction. And I think because we're not doing individual extrudes, we can do individual extrudes as well, but it averages out the normal. But I see there it's not quite, at a 45-degree angle. Maybe because our distance is not exactly the same. So let's try having the exact same distance. And probably that's going to work much better. Actually, we don't even need to use that. Yeah, that's it, right? So if it's the same distance in the X and the Y, we know it's the same everywhere else. Cool. Okay. Now I am going to move everything up, rather down like this. But because we know this is kind of flat right now, I'm just going to select, go into 3 face selection, select these 3 faces, and let's just move them somewhere over here. Okay. That's first version. So let's duplicate that. Add a subdiv. Remember, control 1 or 2 or 3. So control 2 to add a very, very simple subdiv. Very straightforward at this point. And now notice that the bottom is not quite aligning, right? So in the subdivision modifier, if we click under advanced, boundary, make this a bit wider here, boundary smooth. Instead of all, we want to keep corners. Then these corners now become sharp. Okay. So what can we do? We can just select all of these and kind of shrink them a little bit. So shrink those legs a bit. Now I selected something that's not quite right. Let's do this again. Something like that. Okay. And now we can, like do some kind of movement over here. Let me see what I did. I added loop cuts. I'm just looking at my my preparation file that I did. So let's add loop cuts. Change them to 2 and do them in this direction. Now let's go to face selection. In fact, let's just do another one. Change this to 1 cut here and selection. Select these 2. Move them down. I think that's probably too many. So let's delete this loop cut. X loop cuts. when we're doing that, we have to make sure we have everything selected, yeah? And which one would look better? Probably this here. Okay, and now we can move that inside of like this. Now select this whole loop cut, so Alt X, and just add some crease to it. Maybe we do the same here. We add some crease just to make it sharp. Maybe we can do the same here. Although, yeah, that's a boundary one, so it doesn't matter. Well, actually, it would be this here. We need a crease. And that becomes probably a bit too flat. Yeah, we can play with the shape a bit. Can add a loop cut here. Again, I'm doing Control R. So we can, by the way, we can hold and drag the loop cut to move it around. I added two, I meant to add one. Oops. There you go. Selection, vertex selection, and let's just move that to something like this. Let's stretch that out. Okay. Maybe like that. And there you go. So very typical, very straightforward. We can even, what happens if we kind of try to dip this, move it up? That's probably a bit too much. Okay, so very kind of straightforward shell. And now, once again, we can start to modify this a little bit. So what I did in my test file is actually make a higher point somewhere over here. So if we drag some of these vertices and pull them like way up high. In fact, let's undo this. Let's duplicate this as a new with Shift D. Now let's go back and pull these out. And now let's try again with simple deform. As you see, I absolutely love the simple deform one. And now within it, we also have different options, right? So far we only worked with twist. We also have bend, right? So we can bend things on one side or the other side, also along the Z axis, right? So, one side kind of gets stretched. So that's almost like, rotating our mirror modifier a little bit, right? So maybe we do something like this as a starting point, and then Shift D to duplicate this. By the way, I might have not mentioned this so far, but when we do a specific shortcut, because you can see like we can do Shift D and Control A, or Shift A rather. Well, can we do this here too? Wow, yeah, I didn't know. That's so like the windows, the hotkeys are the same. How do we know which one is the active one? So it depends on where our cursor is. We don't need to click in a specific window, but if our cursor is here, Shift A, you see? If our cursor is here, Shift A, and we get our node menu. If our cursor is in the modifiers, Shift A, and we get our modifier menu. So everything is context sensitive. Do we have a Shift A in the outliner? No. What happened here? I hit everything. Oh no. Kind of shrinks it. Didn't know that hotkey. Blender is like Photoshop. You can learn something new every day and still not know the whole program. I definitely don't. I just know like very specific tools pertaining to architectural design and parametric design, but there's so much, especially around animation and sculpting, that I don't know that much about. Now, let's see, what is the modifier that I did here? We did stretch, right? So now we duplicated this. Let's do a stretch, and that has to be like a very kind of, wow, even less than that. Has to be a very subtle stretch, and you can see that we can kind of vary like the top, right? Like it basically becomes more pointy. So let's try minus 0.24, something along those lines. And next, of course, we can just continue with as many different deforms as possible. We can try to, by the way, we can do taper instead of stretch as well. Let's try that. Let's disable this one. Going to this one over here. And if we taper, again, you see how it kind of like tapers along a specific direction. We can do the same in like all the other directions. So somebody asked, is there a way to make mathematical rhythms? So, in a way, these simple deforms are mathematical rhythms, aren't they? As opposed to like having sines and cosines, yep, you can definitely do all of that with geometry nodes. It's a bit of a, let's say, not more advanced topic, but it does require its own time. So we won't get into that here. But in fact, I was just looking at an add-on that allows you to specify like but anyways, let me just go back here and show you. So here we have a geometry nodes. So we have a Shift A and then utilities, math. We have a math node, and in the math node we've got a lot of functions, right? So we got the basics: add, subtract, multiply, divide, multiply, add, and then we have power, log, square root, um, inverse square root, absolute exponent, minimum, maximum, less than, greater than. We have floor, fraction, modulo, snap, ping pong, and then the sine, cosine, tangent, and then arc sines and all those. So you can do all those. Like, you cannot write expressions like you can in Grasshopper, and there is no Python node yet, because that was super useful to have here. So you do have to kind of combine a few of those if you want to have like more complex ones, or if you sort of know what you're doing mathematically and you're looking for an interesting input. If we go back to extensions, I was just looking at this website today to see if there's anything useful to show you guys. So in here, if we look for geometry nodes, so this is extensions.blender.org, geometry nodes, and node quick maths. So here you can input like formulas, and it's not going to do like, in Grasshopper, the scripted node, but what it will do is, and they show it here in the preview, is add like all the maths nodes that you need. There you go. So you have x over 10 times 2, and then the sign of that, right? So it adds all of that. So it does make it a little bit simpler, but you can do all this with just these. It's just a bit quicker. So yeah, take a look at this if you're interested in that. Hopefully that answers your question. We also have like vector math nodes, so loads of different nodes actually. One thing though that we do not have in Blender is an offset node, which is terribly missed. They're working on like a updated bevel. By the way, there's a bevel modifier which I haven't shown, but it works quite well in most cases. But apparently, as part of the work to redo the bevel node modifier, the bevel modifier, there will also be updated code that can be used for more proper offsetting, which will be included in geometry nodes. But at the same time, you kind of saw how we cheated the offset, because this transformation here is based on the curve normal. So like it is kind of an offset, isn't it? I mean, yeah, totally an offset. So even though there's no direct offset, there is still ways to like offset geometry. It's a bit of a tangent. Let's go back to this here. All right, so we have this. We did a bit of taper, right? Or we can do the stretch. And now, just for the sake of it, because I know this thing starts to look quite interesting quite quickly, we can do the taper. Oh, sorry, the twist. So really cool. And you know, if we disable one, you kind of see it's like more, let's say, rectilinear. I mean, the thing is like, even these like little shells, but that doesn't look very good, does it? Yeah, you have to sort of play around sometimes to to get what you want. But sometimes there's like definitely like a useful tool for exploration. So let's add another subdiv modifier. So that's looking pretty cool. And now, in the same way that we were doing before, we can tessellate now. With this shape though, because of the way that it's built, let's just duplicate this, the starting point. So click, shift click, tissue, tessellate. Let's pull this out. Definitely, oh, that's working pretty well. Sometimes the rotation doesn't work too well, but now it's actually working really well. I almost wish it didn't, because I need to show you something. Like if your rotation doesn't go as planned, okay, good. We have some areas that are not quite correct, but now I don't know why that is the case. So let's disable all the deforms here. Let's refresh and now analyze this. Yeah, okay. Yeah, so some of these are definitely going the wrong way. So these ones over here. Now, it's also like hard to debug things when the geometry is quite busy. So a better way to do it is to reduce this mesh, and going back into here, we do have a subdivision, and limit that to 1. So I have something really simple, so we understand a bit better with what's going on. Actually, we have a face here, a few faces. So let's undo this. Well, it's looking weird when we disable, because we've distorted the geometry so much. So instead of that, let's just enable this on cage. So we can test like the continuity of the geometry topologically by inserting loop cuts. The same way we inserted loop cut there. So we can see like we just inserted a loop cut. So that's topologically continuous in that direction. Now, if we do a loop cut here though, you see what's going on. Like this is going in this direction, but we know that we have kind of a loop cut in there. And when we have that sort of directionality, it's important to preserve it. In other words, these two faces here are redundant. So we can get rid of them because we do not need them in this case. So X face, right? And now that we've made these redundant, this becomes very high. But you know what? For the sake of this, let's just keep it. And now, refresh. This should feel a lot more continuous, which it does. Excellent. So let's go back and enable all these modifiers and refresh. There it is. By the way, we can stretch this like we can do it in object mode. So we can do it like at the base mesh or even the tessellation. Because it's at object mode, it doesn't really matter. Like if we update, it's going to refresh itself. Now, somebody had a great question, and that is, how do we make this a solid? So two ways. One is we can go to add a modifier, and we do this on the base, not on the base mesh, on the tessellation, generate, solidify. Make sure, actually, we don't want even thickness in here. It's too complicated, right? And we can add like a specific thickness. And now if we zoom close enough, that might be too little, but you see everything gets a thickness. That's the most straightforward way to do it. Sometimes though, let's see, do we have some kind of strange intersections? Actually, it's looking very clean. But another way to do it is with the component. So let's get rid of this. Solidify. And we're going to change our component. So let's duplicate these two faces, Shift D, Z, and scale along the Z to 0. And that's all we need to do. So now if we update this, underneath, we're going to have the same number of faces. Now, the only thing that we need to do is bridge the ends. Really cool thing is that Tissue has an option to do that. So we can go into tessellation settings. And here under merge, if you expand merge, close mesh, and there's an option to bridge open loops. Once we do that, let's see, did that do it? Okay, so bridge open loops didn't work. So let's try cap hose. I might have to adjust, let's see if we adjust this distance setting, and let's try bridge open loops again. In most cases it does work, but I suspect somewhere over here we have some geometry that's not quite merging, or it's merging too much. And that's why it's not, yeah. You see, we have like these appearing in like strange places. So let's see if we reduce this here to 0.01. Still not quite merging. I think we might be doing like too much twisting. We can manually bridge it as well, by the way. But there is an automated way, and it usually does work. Let's try just a simpler version. Let's disable all these simple deforms. Update that. And yeah, now it works. So yeah, usually it works. I think when we twisted things, some things got deformed a little bit. Now, that's not to say that we can't twist. I love twisting for some reason. I can't stop talking about it. So we can add a simple deform on the actual tessellation, right? So we already have all the geometry. It's all solid. We have all the loop cuts in there, including some that we shouldn't have. What's going on here? Not sure where this geometry topology is coming from. Maybe our merge setting is too much, or sometimes something might have moved slightly off axis. Let's double check here. Let's go to edge selection. This is all good. And this is all good in the Y. So it might be one of those cases where the rotation is switched, but it shouldn't matter because we just have two and everything is like symmetrical along that side. We're merging here with the array. The mirror is merged. So yeah, it's all good. There's some kind of error, which, where were we? Here. But it must have to do with the merge distance again. So as you can see, that's one bit where sometimes it takes a little bit of effort to get right. By the way, if we use constant, the chance of like merging correctly is going to be much more successful. Yeah. Still not perfect. But if we go with 0.001 and use constant, which doesn't matter of the size of the scale, now that's quite good. It's probably the same case that we can use here, right? Let's just go back to this geometry and enable these simple deforms. And let's refresh. So yeah, that's working pretty well. So hopefully this also answers your question for how we can print this as a solid. Now we can take this, um, in all kinds of different ways. We just, so you see right now we work with like the simplest of the simplest components. We're gonna start working with a more complicated component, but before we do that, if we go and just do something, let's just say more sculptural, right? So let's extrude this, add a loop cut with Control R, and that loop cut I'm going to rotate. Doesn't matter what, something like that. Okay. Now let's add a subdiv, get rid of the bottom face, and let's alt click these edges and add some crease. And we have to think about how we want to crease on the top as well. So let's say something like that. Again, the most straightforward shape you can imagine, right? So let's rotate this. And the nice thing is that now, this is base mesh. We're not doing like simple deforms or anything like that. So in a way, we can be more precise with it if we decide to. Maybe this like stretches on one side, or I don't know, one side is a little bit wider. Any kind of solution. And we use our really simple component again. And tessellate. Right? And we've got something that's like, again, looking really good really quickly. I'm going to rotate that face because we want to preserve that level of continuity there. The other thing we want to do is include that ring. So let's go ahead and grab the perimeter ring, which is missing an E. And I'm going to position it here. So, oops, Shift S, cursor to selected, Shift S, selection to cursor, and swap out the shape to this shape here. Plane 0013. We don't have a different material, so let's do the same thing just so it's a little bit easier by selecting this edge loop over here. And first off, adding M1, and then adding M2 and assigning. And now that loop should work. We do have a bit of a challenge here, which is that bottom face, right? We have to decide like whether we want to keep it with it or not. And now I'm noticing that the transform in this instance should be slightly different, and maybe the size. So we can go to this perimeter and expose a few more parameters. So the width and the height, I'm going to keep the same. So let's expose them, and they can be controlled by 1. So we can make that bigger. And let's expose the translation. So we want to have a float from here, and we want to use a combine x, y, z. So we have just the x, because this is a vector, right? So we can adjust the translation. Let's make the default minus 0.5. Plug that in there. So now it's exactly the same, but this is instance based, okay? So if we move it out, you see now it's aligning much, much better. Amazing. And of course, you know, from here, once again, maybe we start to select, what shall we do here? So we can select like similar things in Blender. So if I select this face, let's enable on cage so it's easier to see. Yeah, notice how this changes based on whether we're in edit mode or object mode. But once we're in object mode, it looks pretty good. So if I want to select all the faces with the same material, we can do a couple of things. One is go into material tab in the properties. And in here we have assign, which is the one we've used already. But we also have select and deselect. So we can select all of these here, right? That's one way. Another thing we can do is press press Shift G, and that's a menu pop-up that shows us all the things that we can select that are similar. So we can select similar material. So that's the same thing, but we also have a couple of different options. So let's go now to Edge Selection, select this edge, Shift G, and because we're in edge mode instead of face mode, that menu changes a little bit. So we can select all the edges with a similar crease, which is exactly what I wanted to do, because now I want to bevel those edges. And before I do that, let's duplicate this whole setup. Here. So let's go back in there. The selection is kept. Another really cool thing is like, if you go from one element to another, the selection is completely kept. So in here, let's do bevel. 2 segments is fine. And we kind of get something like that. Right. Actually, we don't want to do the bevel again. And now these new edges, let's go to item and add a bit of crease in here as well. And let's use the shrink and flatten command to kind of push them out a little. That's it. Now, because these are all continuous, we can set that material here as M2. These are the only discontinuous faces. So that's where we would need to do something different. And now, of course, we can continue to kind of softly modify the selection by perhaps sliding these vertices around. So how do we slide vertices? In here, we have a vertex slide. So that slides along its extremities. And it kind of aligns to different ones. See, is that the same as this? Yeah, it is. Or, you know, I mean, what we're doing here is not terribly complex, and we know these are all aligned along one axis, so I can just simply eye it and sort of move this around. The idea is to have these subdivisions sort of appear in different places, right? So every face to be a bit different. Let's isolate this selection. Let's get like a really nice base mesh in here. Let's go to select box. And there's a number of ways to do it. Now I'm shrinking. So let's move this somewhere out here, like that. Yeah. And we can, if we want to, let's bevel this just to get not 3, but 2 segments, something like that. Why is that? Because when we have 2 segments, we have like another area where we can play with like the placement of our edges. So we can get more interesting results, right? So very kind of simple and straightforward base mesh that you can already imagine with the knowledge you've gained so far can create quite a rich. So this backwards like that. Yeah. That's looking, yeah, pretty happy with that. Maybe we just vary this a little bit over here. Maybe over there. The idea is, that like these loop cuts expand and contract in different places. Okay. Maybe. So I'm doing actually quite a bit of work here on this massing, let's call it. The idea is, and this is something I absolutely love with Blender, is just like this level of modification and being able to look around the object from different sides just to see how good it looks. I think we all love beautiful objects, and I want to make sure this looks as beautiful as possible. All right, so now if we refresh, great. I was waiting for this moment. Okay, so here now we have faces that are like, it's getting more complicated to figure out like what we need to rotate where, right? So there's another way to do it. And that's with UV unwrapping. Now we're not going to go into too much detail into UV unwrapping, but the workflow is exactly the same everywhere. Basically, we select one face in here. We can either go to this UV menu or press U for the hotkey, reset, select everything now with the A key and U as well, and follow active quads. So that's all we need to do for this step to work. Now going back to the tessellation, under the tissue settings, if we expand rotation, so far we just did with the default rotation, and that's been more or less good, but you can see once we get a little bit more complex, there's a need to do it in a slightly different way. And that's what active UV provides. And as you can see, for the most part, it's really good. Except we still have a couple of faces that we need to rotate, but at least we know exactly where they are. And it's all the ones here on top. So I'm going to select 1, 2, 3, 4, 5. Right? Yep. It's exactly just these faces over here. So now in tissue, we can just go and rotate. Why didn't these rotate? Okay. Let's try this one then. There you go. And now that's pretty perfect. And we still have like a nice ring around for where we want to keep our geometry. Where we have like the discontinuity between the different sides. Yeah. Okay, so what else can we do in here with this geometry? So in a similar way, like what we did here with this ring, we can do booleans. In fact, booleans in Blender are also modifier based and they're pretty fast. So we can do floors super easily. So first I'm going to do them in on this base mesh, right? So just to demonstrate. So Here we've got a floor. First off, we don't need the ground floor. So I'm going to move this GZ 4 meters up, add a modifier, array modifier, uncheck relative, check constant with Z distance of 4 meters. And now let's change the count. Doesn't matter how high. Okay. Now we're going to add a Boolean modifier. Boolean modifier. And we want to select that object. So we have to sort of either know the name of it. By the way, we can select, that's a good thing to show. We can also use selections from the outliner. So I can select whatever I need from here, but I don't know the name of it. So what are you, plane 014? So let's do it that way. Or we can actually just type. In fact, if I just type 14, we should get plane 014. And now we want to use intersect. And boom, we have our floors set up. Now, instead of exact, there's two solvers. We want to use the fast one. That one is even faster. The exact one is a little bit slower, but like more precise. It's newer. And we've got like floors, which is amazing. It's like so fast. We can also give them thickness with solidify. Let's say something like 0.5. Now that thickness is occurring after our Boolean. So you can see we still have like some intersections in there. We can change the order. And now it's exactly at the face of where we need to be. Now the only thing we need to do though is put this in the place of our tessellation. Now, a couple of ways to do it. One is we just apply it and move it, right? But that's not very parametric. So we can keep this exactly as it is and do the exact same thing we did with the perimeter ring. In fact, let's duplicate this perimeter ring, call it floors. I didn't call these floors floors. So let's call first these as floors. Now we've got two in here, perimeter ring, and let's rename this floors as well. By default, it's floors.001. That's fine. Let's get rid of this geometry nodes. Just create a new one. Tilt button. Select all. Object info to add. And it's easier now just to search for floors. Put that there. And because that's in the other place, when we're moving it, you see it aligns exactly. So that's basically just an instance of that, right? So, okay, we've got this. What if we want to show a section? So Blender does not have a nice like section plane tool like Rhino, but we can use booleans in a very similar way to what we were just doing here. So let's add mesh cube and just make a really big cube. Sort of stretch it. Something like that. Okay. Next, we can go into the object properties. So not the object data properties, but the object properties in here. And then under viewport display, display as we want just a wire. So we can see the rest of the object. Okay. Now let's select and add a Boolean modifier to our three objects, which is the tessellation, the perimeter ring, and the floors. So want the Boolean, make sure it's fast, especially with this tessellation. Otherwise, this might crash. So by the way, let's just save this file. And we do want the difference and select the cube. There it is. Sometimes this is also actually quite interesting, is that we can, you know, have just the face, the facade being Boolean, but the floors stay as they are. So let's just add the Boolean to everything. Make sure it's fast. Add it. And then we can copy modifiers, by the way. There is an option to copy to selected. If you have two objects in Blender, the way it works is the last selected object is the active object. So if I select this object and this object, do you see how this has a slightly lighter outline? That means that's the currently active object. You also know it's the currently active object because that's the name that we see here. Even though they're both selected, we see only that name here. We can also see in the outliner, because this has regular orange and this has a slightly lighter orange, right? So that means that whatever modifiers this object has, if we go now and say copy to selected, it tells you here, copy the modifier from the active object to all the selected other objects. So we can select, 20, 30, as many objects as we want and just copy the modifiers that way. It's just that concept you kind of have to wrap around your head that in Blender, the last selected object is the active object, not the first one, as you might sort of expect it to be. Okay. In fact, let's do that now. So I'm going to select this and shift select that. So that's the last selected one as the active one, and this Boolean copy to selected. And now we can see that it works. So what can we do? If we move this around, we have a proper section. Pretty cool. So that's how you do sections in Blender. Yeah. Clearly, we need a couple more things for this building to work, right? So columns is one, and a core as well. Core is pretty easy. Columns, because of the twisting, what we can do is use geometry nodes to sort of turn these edges into curves, and then based on the normal, sort of offset them inwards to create a column-like layout in there. But for now, we won't do this. However, as you can see, like you can actually we can push this like quite far in regards to what is possible within Blender. I wanted to show you how we can do these booleans also with geometry nodes. Why would you want to do geometry nodes completely? Sometimes you want to combine booleans with some other information or transforms, or in this case here, the reason I want to do it is because I want to slightly either scale inwards or scale these outwards. Again, because we don't have a proper offset, the only thing we're limited to is scaling. But still, that's better than having these intersections. Or, as you can see, this is looking quite nice as well. We can scale them outwards as well and have like the verticality, the horizontality of the floors being read through, with a secondary element being the verticality of whatever these panels end up being, right? And we're dealing with very simple panels right now, but once again, you can imagine that we can, in fact, we can sort of borrow like this more complex panel that we have designed over here. Yeah. Okay, so let's do this again. I'll keep this as is. By the way, I think the Boolean, yeah, it works like tissue. So if I duplicate all of this and we do this, yep, it smartly understands that that should be copied. Okay, so because this is already geometry nodes, let's call these floors instance, and let's get rid of it by creating just a new copy in here. I'm just thinking whether it's worth it to actually do all of that in geometry. The only reason is for you to really know. Like this is one of those cases where it's definitely simpler to do it with modifiers than it is with the geometry nodes. But it's again, it might be good just to know how to do it, because we can combine the array and uh, the booleans together, right? So it all becomes one. Now, this is with instancing in Blender in geometry nodes. Let me just look at the time. So we have about 1 hour and 20 minutes left. There's a few more things I need to cover. Yeah, why not? We'll do it really quickly. I guess it's good because this will also show you how we can instance information. Okay, so we're going to start with like a sort of a complete blank. By the way, this mesh should be manifold, meaning that we should be able to create good floors directly from here. Now, I did lose, I hope we call these floors. Do we call these floors? Yes. So we should have floor 002. Why did I say that? Because in geometry nodes, we don't have any information selected. So if I isolate this, it's nothing, right? It's just a dot. So it's not easy to select. So I think we can get even more precise floors. Not that there's a real need to do that, but we can. It's just the Boolean is going to take a bit longer, right? So first off, let's create our floor. So Shift A, grid. Let's make this something like 20. Connect it so we can see it. Oh, it needs to be bigger. Let's go like 30. Bigger, 50. Bigger. This shape doesn't quite work as a tower, right? Because it's very wide. How tall is it? 106. So that's a proper tower, but it's very fat in some cases. Anyways, so we're going to instance these, and that's a slightly different concept, right? So what we need to do is create a mesh line with the Z count, with the Z offset being 4 meters. So that's how we get it. That's how we make this where it is. And remember, this grid, we need to transform as well 4 meters up. So 4 meters. Now we're going to use instance on points. The points are going to come from this mesh. And this is our instance. And now we're going to have our floor instances here. This needs to be even fatter. Let's go with 100 just to be safe. Okay. And now if you change the count, we get more floors. Okay. There you go. And now we can hover here and we can see what kind of information we have. So here we have a mesh line with 26 vertices. And that's why we get these instances on points, and the instance is a mesh. But these get turned into instances. Now we want to Boolean these. So there's a Boolean node. So we add nope, that's a Boolean, different kind of Boolean. So I think it's, what is it called? Boolean, mesh Boolean. Okay. And this is new in Blender 4.2, which is so important, which is having the float solver. So it's exactly like the Boolean we have. We have float and exact, and that makes things much quicker for more complex geometries like we deal with here in Blender, in architecture with these kinds of tessellations. Okay, so let's we have the tessellation in here. So what we want to use is intersect. Get this and get these instances. However, because these are instances, this is not going to work, right? We get nothing. What we need to do is realize the instances. Realize instances. Now, once we do that, we get our floors. And they're working pretty well. Might want to get rid of that last floor. They're working super well. So that's how you do it with geometry. No, it's not terribly complicated. It's just getting a wrap around the way you do instances in Blender, which is with like this idea here. A really cool idea is we don't have a way to do it, but anyway, Blender, we also have loops and simulations. So animation based for simulations, but also sort of loops that you can do the same transform and repeat it multiple times. So that's incredibly useful. And again, that's one of those things that's like one step ahead, if I may say, from Grasshopper. Cool. So I think I covered everything I wanted with this. Now it's time to move on to something a bit more complex, which is not complex at all. If you, yeah, it's very similar to what we've been doing here, which, as you can see, is it's pretty straightforward in many ways, isn't it? So this time we're going to deal with a planar mesh and more complex panel. So we can kind of understand how that works. So first off, I'm actually going to add a circle. Make it quite big and change the vertices to something like 12. That's a good number to start with. And now let's go into edit mode. Make sure we're in edge selection and extrude. Then we're going to extrude as well. By the way, E, again, I think I mentioned that, but mentioning it again, E again to extrude. And the cool thing is, while we're still active in the command, if I press S now, we're going to scale. So we can scale inwards. Not completely to closing, but something like closing. So that's our shape, our base shape. Maybe we can just make sure we're in X-ray to select everything and lower this down because that's a little bit too big. So we have a circus tent basically, don't we? And let's start first off with, well, let's start with a new plane. Add mesh plane. Here it is. For some reason, that's really far down. Okay. So what are we going to do here? Again, we're going to make this component a bit more interesting. We're going to add a loop cut in this direction. We're going to add 2 loop cuts in this direction. What we're going to do is move this edge somewhere over here and move this edge somewhere over here. Let's select this loop cut and move it out and add a crease. So let's press Ctrl 2 to see how this looks subdivided. And again, in the subdivision boundary, we want to keep the corners. So before I do a tessellation, it's always a good idea, especially with more complex panels, to do like just a simple array of the panel. If it works in an array well enough, it's going to work as a panel well enough. So that works pretty well. We have like what we're looking for is continuity if you want to combine faces. So we have it in the X direction, but as you can imagine, we don't quite have it in the Y direction. So I'm duplicating this modifier. Let's change factor 1. And we've got a gap. We need to address that gap in order to make sure, although that does kind of give a cool effect. There's a couple of ways to do that. One is within this component here by simply extruding this ever so slightly. And in fact, I don't like to extrude this because when we extrude, you see how we lose like this information for the creases. This is a very simple panel, so it's easy to do, but if you're dealing with more complex geometry, that can, become time consuming to add the creases. So instead, what I prefer to do is add a loop cut. And I did it with Control R, by the way, which is what I mentioned before. So now, in order to have this work correctly, all we need to do is drag this vertex, and I'm going to press Control to temporarily snap, and snap into this direction. And now that should work correctly. What we should do though is subdivide after the modifiers, and in this case, make sure we have merge enabled for both of them. So here you go. Now that works exactly as we imagined. So now we have a tileable panel. And we can do the really cool thing here, which is, let's keep these arrays in case we want to change them. But just keep the count to 1 for now. Okay. And now let's select this. And one thing I do want to do is disable the subdivision. I don't like to do subdivisions on the panels themselves. It's always a better idea to do the subdivision on the tessellation afterwards. And the nice thing is that the creases, they carry through. So select this, shift select this, tissue, tessellate. Okay. And here's our tessellation. It's a little bit hard to read, so let's press Ctrl 2 to subdivide. And here you go. That's what we get. Amazing. From just a really simple base mesh and a slightly, but not terribly, more complicated panel. Absolutely amazing. And of course, now you can imagine how we can use this. First of all, because the topology is so nice, even before we do that, let's duplicate this tessellation. Go into tessellation settings. I get so excited about these things. I do them so many times, but still, it's just amazing. And shift the rotation, right? So now we have a rotation going the other way, right? So you can see how different this looks, doesn't it? And we can do the same, like, again, this is like what I call morphologic evolutions. We have the same uh, base topology, but we're evolving we're morphing the I don't know. It's late here where I'm at, and my words are getting muddled together. So let me keep to what I know, which is not words at this late hour. So we can change like the shift. Let's see. That should in theory be different. And the really cool thing is that it's kind of directional because it's asymmetrical, even though it's continuous along this axis. I mean, in theory, we can make this, and I'll show you, like very symmetrical, but we haven't. So if we look at this from top view, we should have a slight kind of kink to it. And you sort of see it here, right? Like that shows it to you. And again, we can kind of vary the scale. So like these things go up, and we can even go, and this is like one interesting candidate where a negative scale could be interesting. Let's try something like more intense, like -3. Look at that. So cool. Like I almost want to twist that, right? It's like, anyways, what was the next thing I want to show you? Yes. So let's just duplicate these two. Bring them over here. And just from the base component, let's add an extra level array. I'm going to select both of these to refresh. Boom. Twice as much topology. Directional though, right? We only have it in one direction. So if you compare this and that, you know, along, let's call this the U direction, we have the same number of subdivisions. But along the V direction, the perpendicular direction, we have twice as many. Of course, we can change that. So if we go here in this array and change the array, now we have it in the opposite. Like we have these doing this. So yeah, again, amazing. Or we can do it in both. Okay, but what if we have this kind of shape and we want to parametrically decipher how many faces we've got? So we can use like this kind of setup for more different options. Yeah. How would we do that? So we're going to construct it with geometry nodes. So we're going to start with a what I call a dummy cube, or what did I add? A circle? Let's add a cube. Doesn't matter what we add because we're going to change it, right? Create a new geometry nodes. I'm in the geometry nodes modifier. When I click, when I click on new over here, that sort of updates everything, right? So yeah, we have what we need here. So we're going to cut this geometry. So I can control right click and that erases it. Again, one of those things that are super nice in geometry nodes because I can have a number of wires that I can cut all at the same time. Okay, so now let's add mesh circle. We're going to expose to, well, all the properties here, vertices and radius. But before we do that, let's maybe work with better defaults. And we can't see that because it's not in the group output yet. Is that more or less the right size? That is 14. Great. So we expose that. We can modify that. That's per instance, right? So we just have one instance now, so it's fine. But we want to kind of replicate this whole setup over here, right? So what do? We extrude once, we extrude twice, and then we scale up. So lucky for us, we can't do everything in geometry nodes. Like we cannot do inset yet. Like well, you can with lots of maths, and there's like a couple of add-ons that come with a lot of geometry nodes groups that replicate some of like the most useful geometry. My favorite one, and I actually have it installed here, is called Hexas Nodes. It does cost some money though, and he has a lot of like useful geometry nodes groups, including, let's see now if I can find them. Direction and follow, distribution. And they get like a lot more mathematical as well, right? So bend, mesh offset, mesh relax, stretch, twist, cube deform, fit size. I thought I saw one that's inset, but maybe it was in a different inset face. Yeah, it's got an inset face. And probably you guys know what an inset face is. Every face gets like inset a little bit. Anyways, so let's just go with what's available for us by default. So extrude mesh. Drop that in there so it automatically connects. We want to change that to edges. Let's drag the offset, and we want to use a combine XYZ. That's just setting a vector. We can use a vector as well. There is a vector input. That's a constant. However, I prefer to use this combine XYZ because you can see that like it also has inputs. So we can either select these with like different values or drag them into the group input. Of course, in the group input, we can also specify, instead of just float values, which is a single value, vector value, which is like, 3 values into it. But then, it becomes a little bit more cluttered. So there's no need, then I don't do it. So the vector is going up, the offset then determines how high up it's going. Okay. And now we're going to extrude again. We can even use the same input here for the edges. And here from the output, we have a selection. So we have only the top faces and only the side faces. So if you drag the top into the selection, it's just the top here, right? So you can see it becomes really clean. Now, Control A, scale elements. We drag this, again, just this selection here. And we need to be in edge. And we scale. And now we've got the same setup that we had before. Let's just do a flat shading. So there's only one node, which is called set shade smooth. Lots of S's for this late at night. And uncheck shade smooth. And now that's shading flat. By default, well, actually, let's see. I shade flat, yeah, it doesn't matter what it's doing because it's all kind of handled now in geometry nodes, right? So uncheck shade smooth. And now we've got like the same setup over here. And we can expose these elements as well. Offset scale. But instead of calling them offset scale, let's call this height 1, h height 1, and height 2. There you go. So that varies, and that in inner scale, it doesn't matter what we make it. Like it doesn't need to be completely close. But that's essentially it, right? We can include like another scale elements in there. So that's that same setup, but now let's duplicate this, and we can say that we don't need 16 vertices, we only need 8 vertices. And we want a larger radius. And you can see because it's not just simply scaling things, it's offsetting things. So now let's continue with our setup over here by duplicating these two twice and going in here and swapping out the component to this. Whoa, that's looking, what happened here? Ah, interesting, very interesting. I set this out as the component instead of the panel. Let's turn this subdivision off just to see what it's looking like. Sometimes mistakes are quite interesting. Now I have to try a couple of things here. So let's duplicate this paste mesh. Add a subdivision. Just add a bit more geometry. We can also keep it, no. Let's do it this way. And now I'm going to add a decimate modifier. And we're going to do an unsubdivide by 1. So do you see what this does here? It basically creates a digrid. So very nice, well-created digrid. I am just curious now. What's this going to start looking like? So if we swap out our base object to this, that's pretty cool. It's a very nice pattern. So you see, now the cool thing about all this is that we can still, if we want to, take it another level and tessellate all of these faces. That'll be too much for what we're doing. Anyways, happy accidents are worth keeping sometimes. So I'm just going to duplicate all of that and just put it somewhere over here. Just make that smaller. So it's clear that's the component. Oh, what's going to look really cool now is we had my favorite simple deform. Simple deform along the Z and really twist this. All right. Pretty cool. Well, not terribly cool, but still kind of cool. I was gonna say we can try to cap these in here, but that's better to do it in the component. Cool. So now let's carry on with the more correct geometry. So let's go here to tissue. So I want to use this component again. Wow. Again, a happy accident. These are quite random at the moment. And because, can we design it? Well, actually, it should be aligning in those directions as well. It's just, okay, cool. That's a nice challenge. I really like this. It's random. You can see how it aligns in one direction. Does it align in all directions? Almost. Almost. So now the challenge is to create this component here. Amazing. Let's duplicate this, just so we keep it nice and tidy. I'm going to duplicate that. Duplicate this component. Sometimes like a workshop, like the work takes like a life of its own, and I'm doing something that I didn't expect to do, but it's so interesting. It's still kind of relevant that I have to follow through with it. And that's what's happening here. Right. So now, okay, the challenge is, because these are going all in the random directions, is to align in a way where it's tileable both in the X and the Y direction. So what do we need to do for that? We need to make sure that everything is really nicely aligned. So we need to stretch this out. It's going to be kind of a challenge. We have 1, 2, 3, 4 faces in this direction, but we have 1, 2 faces in this direction. So we need to add a few faces. Always up for a challenge. There you go. Now we've got the right number of faces. So I'm going to add another loop cut here. And now we want to distribute these. Hold on. What happened? I added an extra loop cut. So now I have 1, 2, 3, 4, 5 faces in this direction. I have 1, 2, 3, 4 faces in this direction. All right. I guess for now, let's get rid of this loop cut. So you have to think mathematically, but come on, it's pretty simple, right? It's just making sure that we have the same number of subdivisions in both directions. Now, let's select all of these. Now we need to use an add-on to do this. And on there. I wonder if there's a way to do without an add-on. Basically, we want to make the spacing even between them. Usually to do that, I use an add-on called loop tools. So space. Yeah, that's probably the easiest way to do it. Now, before we do that though, I want to flatten this. In fact, let's flatten both sides. Okay. And now, so loop tools, where do we get loop tools from? It's again from extensions.blender.org. So you don't even need to go to the website. You can just go here and look for loop tools and install that. So once that's installed, you can right click and you have this menu here. So it has a number of like interesting options. We got loft, we have relax, we have space. So the space is the one that we're going to use now. And now we want to make sure that this is the exact same distance in both directions. So I'm just going to make this 5 by 5 meters. Now we want to apply that scale. So Control A, apply scale. Okay. Now let's make sure once again that we've got our spacing right by selecting those loop cuts. Right click, loop tools, space. Okay. So technically, this should work. Let's just do a sanity check. I'm going to duplicate this, rotate it 90 degrees, and drag it out. And that's not quite aligning, is it? Not at all. Okay, let's start with the simple steps, which is, okay, the lines in this direction. Do we have the right number of faces? 1, 2, 3, 4, 5. No, 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. Yeah, we got the right number of faces. So we need to do the same then in this direction. Yeah. So first off, let's flatten these. So you see what we're doing here, yeah? We're just designing a panel. And select both of these and go back to loop tools and space. So now this should work. Let's duplicate again, rotate 90 degrees and double check. And everything works except the Z. So let's just select one at a time, scale Z0, and bring that to local 0. They have to be in the same location as Z0. Bring that to local 0. As Z0. Add to local 0. As Z0. Bring that to local 0. Now I'm just going to do a sanity check and space these again, because I think even the Z direction might have a little bit of a impact. Loop tools, space, loop tools, space. All right. We've got our panel, which should be available. So let's go back in here and select this panel. Now let's add a subdiv modifier. Does this already have one? It does. Wow, look at that. That's pretty cool. All right. So what can we do here now? Again, like we can kind of really bring this out. Amazing. Because of what we're doing here, this is kind of random, but I can see it's like quasi-random. Yeah. Like some are very continuous, but other parts are discontinuous. We can go even more random now with this. So here in the merge, under rotation, there's just a pure random option. And it can, we can even change the seed. So now it's like a super random thing. Of course, a bit of simple deform might be nice, right? Got like different directions to kind of twist it even more. I think this is using a different one, so let's select the right one here. That's way too much for the amount of topology that we've got, but we can change this to 3. Might work a little better. Not terribly. Let's make it less then. Yeah, some things look better when they're simpler. Yeah, because okay, so this is a good like sort of a design impact. We should either have, and if you think about it, if you look around at like different buildings, different objects, they all kind of follow this rule. We either have a complex massing, right? So the base is kind of complex, you know, it's doing like some intricate geometry. So think of high relief center, right? So that is a complex massing with simple panels. But of course, the panels are not simple because the massing is fairly complex. Or we have the opposite. We have a pretty straightforward massing. So in many cases, even just extrude it up. with more complex panelization, right? So, you know, we might have like different curves. But if we add both, you see the result might not be the best, right? So this is excellent design sort of criteria. So now if we go back and update this, you know, it looks a little bit better. We're just keeping this as simple as possible. In fact, just curious, let's see how it looks even without the subdivision, without the diagram. Yeah, that's kind of, no, I prefer with the diagram. There you go. Might also be because like these are popping out quite a bit. So if we in here go to the tessellation settings, change the scale. There you go. I just discovered that you can do a negative scale like when I was prepping for this workshop. So now I'm always curious, what does it look like when it's inverted? That's looking really nice as well. But for now, I'm just going to keep it positive. Cool. So again, happy accident. Wasn't expecting that, but I think it came out quite nice. Even though this on its own, even when it's disconnected, is also quite nice, isn't it? Yep, I also quite like this thing. Of course, if we do a subdiv onto it, which we do have, but it's disabled, then in some cases it connects, probably in others it doesn't. What we do need to do is, again, boundary, smooth, keep corners. And yeah, in this case, it doesn't matter because like some edges are higher than others. They're like on a different axis. So yeah, that doesn't need it. So many variations. Okay, so now, once again, let's go back to this and make sure we have the right base object and the right component. And now make sure subdiv is enabled. And we need to adjust the rotation. Now it's going in. For some reason, if we check the normals, when I was doing this, I got the same thing. Is when we extrude this way, we need to flip the normals. So let's add a flip faces to just that. So now if we change it, it should work fine. Cool. So let's go back to default of 0. In fact, I'm just going to delete all those, duplicate this, just because I think it's also nice to see what it's doing on the other side. Keep this. So that's what exact same component we were using here. Yeah. So now let's duplicate this and choose just 8 sides. Make it a little fatter. And now that's going to update itself. So we have less sides. It's starting to look quite a bit different, isn't it? But I want to show a couple of different things. Let's make this panel more complex. Maybe we should use a bit more sides. Let's try 12 sides. So there you go. There you go. Okay. So we kind of made this continuous in one direction, but I'm going to get rid of these faces here, X faces, as a loop cut. And I'm going to put let's go into object mode and just move the origin, move it, press Control to snap and put it over there. So let's add mirror. And instead of X, we're going to duplicate Y. All right. So now we know, because of the way that this is aligned, that it's also going to work quite straightforward. So let's duplicate this shape. Oops. I am only duplicating the origin. Let's duplicate this. And now use this component over here. And now, I mean, in a way, it's starting to look quite similar, isn't it, to what we had before? Of course. But I actually went with like a, oh no, I lost that component. Okay, let's undo a couple of steps. There it is. Not sure why I didn't duplicate that. So let's duplicate that. Let's duplicate that. Do the same thing. Get rid of these faces, X faces. Move the origin point. Add mirror. Drag that all the way up. Change it to Y. Okay. So far, kind of, not looking very different, is it? But instead of having just this component, we can do the same thing that we did before, which is have two components. So we're going to do another tessellation. And those components are going to be really simple. Getting quite advanced here. So that's going to be like a couple of nested things, right? And this component, you're going to recognize because I use it all the time. It's so cool. I use this all the time. So that's our panel, right? Panel 1. And we had M1, M2. Let's call this, what should we call it? S1, S2. So we'll create two new materials, S1. S1. S2. Let's change this to some material that we can recognize. And this is S2. We don't need to do this with tissue, right? We can do this like more simply modified, but I don't know why I prefer to have the control that if I need to change something, I can always change it. So it keeps it like as parametric as possible. Okay, so let's name this component S1. And let's duplicate this. Get rid of this loop cut. X edge loops. Go into object mode and name this S2. All right, so now when we do this initially, because we haven't done it initially, we go to tissue. We just have the base mesh and we click here on the material icon. Okay. So now that gets it done for us, but for some reason it didn't work correctly. And I think it's because the rotation is not quite right. Also, we haven't subdivided anything. So instead of subdividing, we're going to do the same thing we did before, which is array. Make sure merge is on. Add a couple. We can scale this down. The actual size doesn't matter this much. I'm noticing like my edges are a bit finicky. It's because I'm probably quite far from, not that far from the origin. So I'm just going to change my clip start to be something like 0.5. Is that a bit better? Kind of looks the same. Anyways, so let's refresh that. There you go. That's exactly what we want. Now we need to modify this panel just a little bit by dragging these out a little bit more. What's really important is if we look at a top view, the edge is not one of these edges that kind of like sticks out. Yeah. We need to do it a bit more. Still doing that. Is it? Yeah. Usually what I do is I go and just drag this out a little bit. The annoying thing is that you always have to remember to do that, because if you don't, it kind of sticks the way it does. So let's add a few more here. There you go. Okay, so that's our component. Again, I'm just going to drag this out a little. So now we got like a base mesh. This is a component that's still kind of tessellated. And we're going to use that onto here. So let's go ahead and swap out the component. This. And that's what we get. I think for this particular version, for it to look good, the way I was testing it, first off, do need to increase the scale a little bit. That's the other nice thing about having this kind of control, is that we can go and sort of modify this at any point that we want. Like, yeah, that's the really nice thing, is what I'm doing here. Just a couple of modifications, moving a few loops around to completely change the look of this. So, and because we set this up in geometry nodes, I think I want to do 16 sides. Let's make this something like that. Now, let's refresh. Did I update that? I didn't. That's the only thing we have to remember, is we need to update that, and also we need to swap out. Nope, that was the same. This is the component. What we want to do is swap out the base object. There you go. That's more like it. And the really nice thing here is, oh no, it doesn't. Why doesn't it do that? I was hoping that this gets carried through as a sharp edge, which it doesn't. So that's okay. We can go in here and mark this as a crease. So we have like a sharp edge. There you go. That's a little too sharp for my liking. So maybe it's not that edge. Let's decrease the crease. Maybe this is the one that gets the crease. Let's try that now. It's a bit too intense than the last time that I did it around. Anyways, we can make it work by just decreasing the scale a little bit. So let's try one. There you go. Let's increase the number of subdivisions. There you go. Now, again, like, I think these kinds of things are good to test in both directions. So let's go now in rotation and just change this. I'm always curious as what it looks like. Even in that direction. And actually, if we kind of expand that, that starts to look quite interesting. But I think part of the issue is that this effect is like a little bit too much. So we can reduce, make it a little bit more subtle. Yeah, something like that. So unfortunately, when we do that, again, we just have to adjust a couple of things here. Okay. There you go. That's looking a bit better. And yeah, because we dragged this edge like too far out, that became like too subtle. I want it a little bit more compounded, except making sure that this bottom edge is in its correct position. There you go. That's looking more like what I was imagining before, which is very nice, you know, very controlled, and still has like a lot of variation happening in it. Now that should probably look a bit better as well. Yeah. In fact, this one would look better with less sides. And probably better if it's rotated, because when you're ground level, you kind of want to be able to read those. Or again, let's try negative scale. Yep. Pretty cool. Pretty interesting. Let's try positive and change the shift to 3. Yeah, that's what I was imagining. If it's in this direction, we definitely need like a different component on top. Like this works quite well on the sides, but not that well on the top. Although from up high, I mean, it's a mandala. A lot of what I do tends to look like mandalas. Look at all these. They're so beautiful. So let's go back to 1. Yeah. I'm only doing that because it's gonna look, well, not really. That's pretty good. It's pretty nice. Okay. Gosh. Need to hurry up here. Right. So I think I covered most of what I wanted to. Now, with this shape, I'm going to backtrack a little bit. I did say we either need to have a complex panel, which we do in this case, and a simple base mesh. But that base mesh can still get modified a little bit. So we can do it either with a lattice modifier, or let's just duplicate this here. You know what I need to do? I have to try my simple deform here. Along the Z. It's nice because it's almost like a diagrid. But does it make a difference? Now we do have a bit of directionality here, so we do have to see how that works. Okay, pretty happy with that. So now let's add a simple lattice. So that's an add-on, and that's an add-on that you need to download. So now Blender has lattices by default, but you kind of have to like manually like adjust them. They're not like in Maya where you add a lattice and it sets itself up automatically to the bounding box. So if you look for simple lattice Blender, you should get this add-on. So then you go to code, download zip. Once you have that, in Edit, Preferences, Add-ons, Install from Disk, which is in this. They made it quite hidden now because the idea is that you get as many online extensions as possible. So you go in here, Install from Disk, you choose the zip, and it installs itself, and then it should simple lattice. It should default. And what does that do? It just creates a lattice around like the mesh, and then it creates a lattice is basically a modifier as well. Yeah. So that's our lattice here. So we can modify things and kind of stretch them, push some sides out, add more subdivisions. And then all of that, of course, naturally, adjust itself. And similar to everything else, like with the lattice, I try to keep it like pretty simple. To make sure that it looks fairly good. I said that, and this is already looking a bit complex. We can change the interpolation. Cap move ROM is going to be much smoother. To get to something that looks like this. Cool. Okay, so now we can crank up the subdivision a little bit. And let's see if we adjust the scale a bit. Yeah, so that's looking really nice. I just remembered one setting could be very nice in here as well. Within tissue, we have the option. Let's see. Maybe not. Let's try it out. Okay. Nothing prevents us from trying things out. So we want to mark these as seams. Now in the tissue settings, we can dissolve those seams. In other words, the topology is going to change a little bit. We're going to have two less of edge loops here. So, oh, by the way, I wanted to mention that I have a Discord channel. I just saw that Mike dropped some things in here. And let me find the link. So it'd be really lovely to see what you guys are doing with Blender over here. Okay. So carrying on with this. So now in the tissue settings, if we go into merge and we expand that, you see there's tissue is like a program on its own, right? I mean, basically this has been a workshop in tissue in a way, hasn't it? Yeah. And I actually there was another design morphine Blender session, which was with also with tissue with 3D printing, but very different than what I did. It was great because I learned a lot of things on that workshop as well. So here in merge distance, we can dissolve seams. So, oh, we haven't updated our component. Let's update this. And yeah, that's looking even better. You see like it deleted some geometry in there, which means that like when we do the subdiv, it's looking even like better. So I'm doing quite a few. Let's do this here. like that. Yeah, that's what I wanted. And there's nothing to prevent us from making these seams creased. Maybe all of them, actually. That's it. Pure smoothness over here. Pure sharp smoothness, if that's possible to coexist. It's really cool. Now, one thing I just want to try out is if we add an array, not in this direction, but in the Y direction. Make sure merge is on. Just curious whether, no, not good. Don't like it much. So what if what about the other direction? I don't know, what do you guys think? Got two options here. Let's duplicate these two together. Keep this. I, by the way, just so you're aware, I'm going to share this file, but it's going to be a little bit more simplified. There's too many things and a lot of them are actually repeating, right? We're doing step by step. If you follow the tutorial, you should get like most of what we're doing. But for the purposes of sharing the file, it's going to be like a much more simplified version of this. So it might not include everything that you're seeing here. Okay. So this one just gets one. So let's compare. Which one looks more interesting? I'm going to isolate these two. I think I like this one better. With the fewer ones. Although this one here, if we increase the scale, could be quite interesting as well. Because it can stick out a little bit more. Whereas this one, if we increase the scale, it gets a bit, how shall I say? Yeah. Well, we can say, happily agree that they're just a little different. Both are great. It depends what we're doing, right? So with all of this, there's infinite possibilities. They're all super easy to do. So we get to a point like, how do we, this is perfect actually. How do we decide what's better than the other? That's where like proper architectural criteria needs to come into place. If these are panels, if these are sites, how big are the panels? What is human scale, right? Maybe this is too big for human scale. Maybe that is better, right? Because it's more constrained. Also, maybe this is a little bit more buildable, right? Like if we imagine how these are unwrapped, like what do they look like? Are these all panels? Of course, you know, here we get into a situation where each panel, if this is panelization, right, is quite different. Of course, now they are machines that are that can do that. There's basically these molding machines that Zaha Hadid used for the Grand Rabat Theater in Morocco, where they have, and it's a company called New Technique that did the facade design. And what they've got is, I'm not sure who the GFRC contractor was. GFRC, so glass reinforced concrete panels, so lightweight concrete panels, which they put onto a metal frame. They have like these molds which use actuators, and they can have, you know, 20, 50 actuators, which can be adjusted in different heights. In other words, if you have like two of these actuators, you can create custom molds per panel, and the degree of difficulty is not as much as just having one mode for multiple panels. So technology is improving where these things, these kinds of shapes are becoming like more and more um interesting, feasible, let's say. Cool. Okay. So we're wrapping up with this. I just wanted to point this out because, yeah, it's excellent. Like, what makes one of these better than the other? Nothing at the moment, right? What are they? Are they objects? Are they buildings? How big are they? Like, they're kind of modeled to a building scale. So I could put a human on here onto here. So let's find a person. Yeah, and when we do that, actually, you see right away that like this scale is probably a lot more appropriate than this scale here. But again, it depends what we're doing. If this is a stadium, which, the shape is not actually for a stadium, but it might work for a shell for a theater. We need to work out the internals, which we haven't. But for pattern-wise, it could work for that. And that could work pretty well in regards to that scale. Let's just say that we prefer that. How did I load the person? I have a person in my default file. These are people that are really low poly that I got from Sketchfab. I'll show you where I got them from. Sketchfab.com. People. Make sure they're downloadable. And I think, can you order by most liked, maybe? Yeah, it's these low poly people. So there are loads of them, and they're all like super low poly. So it's a free download, so I definitely recommend it. And I just use like one of those scale figures, and I just have it like in Blender. By the way, I didn't talk much about this, but you can set up like your own default file with like specific settings that you want. In fact, like what I well, we didn't really change much. Like the preferences stay as they are. They're one thing, but the actual like UI and outline, that's a different thing. The only adjustments to the UI we did is having these columns visible, which maybe you don't want to do, but if you do and you want to always have them, like if we create a new file, you have to go to defaults and save the starter file as a default. All right. And are there other things that can be loaded? Yeah, loads of things. So you can load other Blender files. You can load information from other Blender files. You can also link it, but I won't go into detail into this. You can look it up, and if you Google linking Blender files, and you'll see how it's done. It's pretty straightforward. Blender also has an asset manager. Um, and I will show you, for example, here you can see all the low poly people. And yeah, I mean, if you guys been around the free internet, you probably recognize a lot of these people from like all the websites, like that offer scale figures for free. I think they have like some kind of, I guess, an OBJ or an APX format or something like that that I downloaded and I just put into like an asset library in Blender, so I can always drag and drop them if I want. And they're add-ons, paid add-ons for like trees and people and cars. Basically, cars are probably the most important thing, and people. And this one I haven't used even yet, procedural crowds. But trying to find Polyhaven. There you go. These are the ones that I recommend the most by Polyhaven. And they've got, oh, sorry, Polyhaven is actually free, but this is a paid add-on. But you can get like HDRIs from there. I don't know if you know, you probably know it by now. And also models, but their models are, I guess, kind of, they have a certain style of it. The one that I wanted to show you, I don't have it loaded here. Oh, there it is, Polygonic. Yeah, so these are probably the best assets that I recommend for Blender. They're a bit pricey, but I think for these kinds of things, you pay for it. Again, because Blender is, free and open source, including the rendering engine, it doesn't come with like any asset libraries, like, all the other rendering programs right there. So you do have to um, purchase. So I'll show you the ones that I recommend the most. Oh, funny spelling. It makes it a little bit harder to find. There you go. So there's a special website for Blender related assets. They have all kinds of things like add-ons, models, uh, things like that. So if you go to these guys, they're architectural visualizers, I think from Poland. So they have Traffic and Botanic. I highly recommend both of these. And the price, that's not that high. Like this is the one that you should get, the Traffic Full. So this is just cars, right? And you always need cars, like good car assets. And the other one is Botanic, and Botanic is greenery. And the quality is pretty good. It's not terribly high poly. Um, so yeah, definitely recommend these. You can even get like the light one. Oh, they even have like a starter one. These are definitely worth it for populating your assets with things. Cool. All right, let's render because we're really running out of time here. So let's duplicate this. In fact, I'm going to put it in a new collection. We didn't really talk about collections this much, except in the beginning, but we can create new collections, you know how, but also if we press the hotkey M, let's create a new collection. And now I'm going to turn everything else off. So let's, how far are we away from? I think we should still be fine. Like if we get too far from the origin in Blender, just like in 3ds Max with V-Ray, sometimes you get artifacts, but I think in this case, we're not that far for basically like the values, like pixel values or something, they get because they're using floats, not doubles. So it has like unlimited number of hexadecimal places, which makes it less precise. Okay, so let's go to the shader editor. So we're going to use Psychos, right? So you go to rendering properties, Psychos, sampling. The defaults are really high. You don't need to go that high. So max samples, 32 is fine for viewport. And for the render, 528 is fine. Make sure denoise is clicked on both. And you can leave automatic for, excuse me, it's getting quite late here. You can leave automatic for the viewport. For denoise, we got open image denoise, which is higher quality, but it's a little bit slower. And then if you have a NVIDIA GPU, you can also use optics denoiser as well. Oh yeah, now they have an open image denoise GPU option, which is brand new. That's all the settings we're going to adjust. The other thing is in color management, we can change the look. By the way, let's try these settings out now. That's a totally default world. So by the way, I'm in shader editor, world. So if we go in here, this is how it looks. So not terribly exciting. Shift A, search, and there's a sky texture in here. Once we add that, makes things more exciting, but still kind of, like very default. And we can change the sun intensity with the sky texture, by the way. It needs to be like much lower. And there's a trick, but basically I saw somebody on YouTube do it. There's no like other way to figure some of these things out, right? So if you want the background to be white, but still have the sky texture being applicable, we add a mix shader, duplicate by Shift D this background node, plug it in here, make the strength to 1, and the factor is going to be camera ray. There it is. That's all we need to do. Maybe we can make the strength to 2 in here. Make sure this is pure white. And now we have something that works a little bit better. So that's your default sky setting. And if we turn off the wireframe, you can see it already works like really, really well. But what I found out is for like these kinds of objects, having like a 3-point lighting works even better. So I'm going to disconnect all of these for the world, and we just end up with black. So let's add now a couple of lights. Make sure we make this the active collection. Call this ground plane. Shift A, light, area. And we can change this to, let's make the radius like bigger, 100 meters or so. So that's our like top light. Let's turn this on just to see how it looks. And this needs a lot more intensity. More. Just need to keep adding 0 sometimes. 1 less. There you go. So this is like a top faded light. Let's duplicate this. Make the size smaller. Also, we don't need to use like that wide of a spread, even in here. Like this could be like much more directional, so it makes the light more focused. This one can be even more directional. 100 degrees. Now let's rotate this in the X direction 90. And we can change the output of this so it's a bit stronger. And maybe we got something like this. Let's move this a little higher. And now let's play with the position of the light. Need to rotate this. Just not sure which way, so we get like a little bit that's actually really good. We get like a good shadow and a good light. We have to adjust something here, which is this bottom face. Let's scale it along the z-axis to 0. There you go. So that should be nice and flat, except it's not exactly at 0. So let's make sure it's at 0. There. Okay. Now let's duplicate this light and put it somewhere over here and change the intensity to something, let's say, less intense. It could even be more directional, maybe with a smaller radius. I think that top light power might be too much. So we can reduce that a bit. We want to have some, but we want like this to be our main working light. Let's try 4,000. So this is the kind of thing that just takes, lots of trial and error. Cool. So that's looking pretty happy with this. Next, let's add like materials. Got a new material here to the ground, and let's call it ground. Now, we need to, again, remember, not the viewport display, but we want to adjust the surface color to something that's somewhat darker. And I always like to add a little bit of texture, like a noise texture. So if you go into shader editor, change this to object. And now Shift A, search noise texture. Let's plug this in here. See what it's doing. We need to change the scale to something. Actually, with noise, with shading, the texture is kind of the inverse of what you would think. So it actually needs to go like to quite large. And then we need to change the roughness and the detail. There you go. So I'm already quite happy with this. Now we can use this noise texture for a couple of ways. So I'm going to add a mixed color node, and this is going to be our factor. Or even better, we can use this as a multiply factor. We can change the intensity. We can add a color ramp, which acts essentially like levels do in Photoshop. To increase the contrast between the lights and the darks. Okay. And now we can use this same setup to drive our normals. So we add a bit of bump and also our roughness. So there's a bit of a variation in the reflections that are based on these things. So for that, we're going to need a color ramp again, just so we can control it. Otherwise, like plugging this is going to be way too reflective. Whoops, not normal, roughness. You see? So what we usually need to do, so black is the most reflective, white is not reflective at all. So I like to change this black to some kind of gray over here. It's already looking quite nice. And now let's add a bump node to convert this. We're going to plug this into height, and this gives us normals. And we need to turn down both the strength to something like 1. Whoops, 0.1 and 0.1. So we just have like a very subtle amount of bump here. Yeah. I'm not sure which one looks better. Let's try. Is it going to be this? I guess this makes it more subtle. Maybe we do use that. Maybe we increase the distance slightly. Too much. Wait, whoa. I wanted to say 0.2. There you go. Something nice and simple. Again, might be a bit too reflective. Something like that. Now we can use the same kind of material here. So instead of we created a new material, but we're not going to use it. We're going to find our ground material. And again, just like in geometry nodes, you see where it has the number 2. That means that there's 2 objects that use that same data. Let's make this unique by clicking on that 2. Now let's change the color, similar to the background that you see that I'm using, to something a bit more red. Probably a bit brighter as well. And we're going to make it metallic. So we can increase here the metallic to 1. Now that's too bumpy. So let's reduce the multiply factor. Maybe reduce the light here a bit. And maybe this is too red, so we can decrease the saturation. Default is RGB. I always use HSV, hue saturation value. Something like that. And now there's just, you know, a bit more play perhaps with the light that we need to play with. Maybe with this color here to get like a good level of variation. Maybe we need to increase the detail here. That scale might work. So we just want to add a bit of noise. It's always a good idea to have a bit of noise. And now let's look for an interesting angle. I am not quite happy with the material. But I'm not sure what's not working out that well. Maybe it's the color. But if we do this kind of color, all right, we also need to auto smooth. It's going to help a lot. Yeah, we want to make sure that we have like a good level of subdivisions here as well. But somehow it's feeling a bit too red. So because it is a metallic surface, what we might need to do is increase the intensity of this lamp. Maybe of all the lamps. This one here as well. Might want to bring this a bit closer. And the spread needs to be more. Same here. Once we increase the spread, it's more lights, like the same wattage, but spreading across a wider area. So we need to increase the power. There you go. Maybe one needs to be like a little bit higher. Whereas the other one, let's keep it like 90 and lower. Almost like as a backlight of sorts. Sometimes it is also helpful to add just a little bit of a background, because right now the background is completely dark. So I'm going to duplicate this node, plug it in here. Instead of white, we're going to have some kind of gray. It's not really doing much, is it? Okay, yeah. So the other thing I'm noticing is actually some of our sharpness is not working right. So let's go in here. And let's see. Are these all creased? They are. So really cool thing is we can specify that only our creased edges are sharp. Not quite working out the way that I need to, because everything else is then not sharp. So what happens if we shade it smooth? That might work better. Let's add now Nope, looks exactly the same. Right, so I'm afraid the only thing we can do is play with this angle to get it to look a bit better. Yeah, that's already much better, isn't it? And another thing we can do is go in here, Shift G, select all the ones with the same amount of crease, and let's mark these as sharp. Now that should make them super nice and sharp. Now I debate though whether you need to be that sharp. Maybe they don't. Yeah, I like that kind of like subtle softness that we've got going on here because we're doing a lot of subdivisions in the way that it's catching the light. So yeah, that works pretty well. Cool. Okay, so we're nearly there. So now we can add a camera. I already have a camera in here. If you don't, you can go to Shift A, add camera. And if you have multiple cameras, the way to make it active is to click this icon here. And to align a camera, we can go to, once you have the active camera selected, go to View, View, Align Active Camera to View. So now that aligns nicely. And we can still modify it. So if we click on this lock button, if I change the view, I'm actually changing the camera as well. Which is really cool because we can kind of work around our object here to find a view that looks nice. I think I need another light in there. I think, yeah, this view works really well. You get a good sense of it all. But we can change the camera. Let's click the unlock so I don't change the camera anymore. And in here, I'm going to change the resolution to 1080 by 1080. I'm going to get rid of this background again. So we just have a black backdrop. And we can adjust the angle to something like 35. And now I can still slightly move the camera around. Maybe make sure that we have, let's scale this. There you go. Cool. That's it. And now we can go to render image, or I press F12. One last thing that I wanted to show you is in render properties. Here in the look, we have high contrast. We also have very high contrast, or we have low contrast as well. We also have like some, Blender has its own compositor, which just got updated to work with the GPU. So that's like almost like having After Effects or DaVinci Resolve Fusion inside of, like, so you can do a lot of color corrections and things like that in here, which is useful for animations, right? Instead of just using something like Photoshop or Affinity Photo for a single image. But you can do some basic edits here, like, for example, adjusting curves. In here. And we can also, if we need to, increase the exposure. Still work with high contrast. Now that red is very red. So once again, I'm going to turn down the saturation a bit. Not sure. You know what? Maybe we just leave it as is. And in fact, the curves, like this doesn't work with that high of contrast. I'll just leave it at the base contrast. Exposure 0. I think we can increase the exposure to 1. This is, by the way, different than adjusting the exposure of the image saved, unless you save a 32-bit image, which you can do. You can save an EXR file here to edit in Affinity Photo, for example, which in this case I won't do. Okay. So now let's press F12 to render. And we're done. Not really happy with this background. I think it needs something with the scale, maybe. 20. And more detail. This scale needs to be increased as well. Let's try now. Yep, that's a little better. Cool. So we're near the end. And to save a file, you can go to Image, Save. And just gonna do my typical folder naming. And I typically save as a PNG image or one. And I think we're pretty much wrapped up here. So I don't know if anybody has any questions.
Thank you so much, Dimitar. It was awesome. I like how in-depth and all the options and everything you did, like on this geometry. It's like with this kind of tools, you can just go forever and ever and make all these cool little tweaks and adjustments and really powerful stuff.
Yeah, it's like both powerful, but not like terribly complicated. As long as you're willing to dig into a few options. Maybe that's the complicated part, is finding the right option to tweak.
Sure, yeah. Yeah, important. Not to be complicated. And it seems people are liking it. Yeah, it's really good, these kind of ones that go, these kind of webinars that go more into detail with all the options and settings. I think there's no question. Yeah, well, I guess we can end it there. I know it's late for you. Thank you so much, and thank you everyone that attended live.
Yeah, my pleasure. Thank you for all the guys for participating. And yeah, looking forward to see what you guys, create with these sorts of workflows. Mike, thanks again for the invitation. And yeah, we'll see you. Hopefully, would be lovely to hear from you. I'm definitely losing my ability to speak by now. So
Yeah, make sure that you join the Discord there. I'll put the link again for you. And yeah, show the Dimitar what you make.
awesome.
Okay. Thank you,
Cool.
everyone. See you.
Thanks. Bye bye, everybody.